Hi, good morning everyone. Welcome to Unacademy, India's largest learning platform. This is Shefali Singla, and in today's session we will be covering all the types of counters and also we'll learn that how to design a counter. Okay, so this will be the agenda for today's session, and whatever previous year questions has been asked on the basis of counters, that I'll be taking in the next session. In today's session I'll be explaining the concept through some extra examples. So before starting with the session, let's talk about what this Envision batch is and what is its goal. So this Envision batch basically targets on GATE 2021. Daily in this batch, which is on our YouTube channel, that's Let's Crack GATE CSE. Daily we are having 7 sessions of 1 hour each duration, which starts at 4 p.m. and goes till 11 p.m. This is basically an English batch course, and currently general aptitude, discrete mathematics, computer networks, data structures and programming, compiler design, operating systems and algorithm is going on. As you can see that I have started with the concepts of data structures and programming, which is very important subject from GATE as well as from placements point of view. In the GATE exam, this is having the highest weightage among all the technical subjects, and from placements point of view also this is one of the very important subject. चाहे आपका written round है or be it the interview round or the coding round, you should have a good clarity over the concepts of DS and programming. So if you want to follow the live sessions on data structures and programming daily, you can follow the session at 7 p.m. to 8 p.m. Today also we will be having the session in which today we will be covering the concepts of binary search tree properties we had discussed. We'll learn that how to perform different operations on the binary search trees, and we'll also analyze the complexities for the same, and whatever the drawback will be coming up, we'll be removing that drawback in the next approach. Before this, we have covered all the concepts of arrays, stack, queues, linked list along with the previous year questions. By any chance, if you have missed the live sessions, in that case, you can follow the recorded sessions. If some doubt or query is coming up, you can write in the comment section and definitely you'll get the response for that. And apart from this, we are having the free special classes on our platform, that is Unacademy. For that, you can download an app that is Unacademy Learning App. This app is available on both the Play Store and the Apple Store. So by downloading this app, you can access the free sessions as well as the subscribed sessions. Apart from that, you can participate in the live quizzes, you can attempt the questions of the test series and so on. So major benefit क्या है, आप किसी भी time पे you can watch the sessions. So while downloading, make sure that you are downloading the correct app, that is the learning app, because that is for the learners. Other app is for the educators. हो सकता है इस point of time पे आपके लिए educators वाली app might not be fruitful. So this is about the learning app, and in case if you want to cover the whole syllabus in detail or you want to join the crash course, okay, because for GATE 2021 approximately 2 months to go. So this is the high time to join the crash course. अगर आपने self study की है, then also crash course will be very beneficial. Reason is जो भी आपको tricks और tips आप नहीं पता लगा पाए हो, those will be shared during the crash course. So you can join that. For that, you have to subscribe for the plan. We have 2 types of subscription plans, the Plus subscription and the Iconic. Plus is our basic plan to get started with, and Iconic takes your preparation level to the next level with the help of personal coach. I'll be discussing the benefits of both. Plus में जो भी benefits हैं, those benefits are there in Iconic as well. Iconic में some additional features are there. पहले हम common features की बात करते हैं. Common benefits क्या है? First one is you will be able to access unlimited interactive live classes which are taken by India's best educators. That's why they'll be sharing their experience, tips and tricks during the sessions. By any chance, if you are unable to follow the live sessions, in that case you can follow the recorded sessions, और जो भी आपके doubts होंगे, doubt solving sessions are there. Plus and Iconic courses are designed in such a way that every 4th session will be a doubt solving session along with the practice session. In this, you will be provided with the practice problems that you have to try, and whatever doubts will be coming up, those doubts will be taken in the doubt solving session. So these doubt solving sessions are also the interactive sessions, so you can interact with the educators as well. Apart from this, we have the weekly quizzes in these courses, so that कि जो भी आपने पूरे वीक में लर्न किया आप उसको एनालाइज कर पाओ, इवेल्युएट कर पाओ कि कितना आप लोग उसको अंडरस्टैंड कर पाए और किस लेवल की आपकी प्रिपरेशन चल रही है. अगर प्रिपरेशन अच्छी चल रही है तो जो भी आपका स्केड्यूल है कीप ऑन फॉलोइंग दैट स्केड्यूल. बट इफ यू आर अनेबल टू परफॉर्म वेल, एक तो आपको अपनी मिस्टेक समझ में आ जाएंगी, मोर ओवर आपको पता चल जाएगा कि आपको और कितने एफर्ट्स डालने की जरूरत है. सो दिस इज वेरी वेरी इंपॉर्टेंट. Apart from this, structured courses and PDFs are provided for all the sessions. Live tests and quizzes are also included in the Plus subscription. Iconic में ये सारे benefits तो है ही. Additional benefits के first one is you will be getting a guidance from the personal coach with the help of which you can identify your weak area and the strong area, so that कि आपको एक direction मिल जाए जिसमें आपको efforts डालने की ज़रूरत है. Second one is personalized test analysis would be done. Study planner will be provided to you. And the most important one is preparatory study material is also included in the Iconic subscription. Preparatory study material में जो भी आपको theoretical concepts चाहिए, जो भी theory चाहिए, जो भी practice problems are required, everything is included in the preparatory study material. So if you have got that, तो आपकी तरफ से सिर्फ जो efforts required है, that is for the practice. Okay, so this is about various subscriptions. Plus and the Iconic. Under Iconic we have two subscription plans, 1 year and 2 year. 1 year Iconic subscription is for 50,250 and 2 year Iconic subscription is for 74,000. But if you are going to apply this referral code, you will be getting 10% discount. So for 1 year subscription you have to pay 45,225 and for 2 year subscription you have to pay 66,600. बच्चे अभी जो पैटर्न है उसमें थोड़ा सा चेंज है. इफ यू वांट टू फॉलो द फ्री स्पेशल क्लासेस, फॉर दैट आल्सो यू हैव टू यूज द रेफरल कोड, राइट. बट ऑब्वियसली फ्री क्लासेस है तो आपको पे कुछ नहीं करना है. जस्ट टू अनलॉक द फ्री प्लान यू नीड टू अप्लाई द रेफरल कोड. सो बाय अप्लाइंग दिस रेफरल कोड यू कैन अनलॉक द फ्री प्लान. And in case if you want to upgrade the plan to the Plus or the Iconic subscription, in that case at the time of checkout this code will be automatically applied and you will be getting the 10% discount. So the system will ask you to pay 45,225 for 1 year and 66,600 for 2 year. Good morning Surbhi. Here you are paying approximately 20,000 extra for 2 year subscription. So this is basically beneficial for the students जो अपने प्रिपरेशन अर्ली स्टेज पे शुरू करें. लाइक बीटेक के फर्स्ट सेकेंड और थर्ड ईयर में यू हैव डिसाइडेड कि यू हैव टू गो थ्रू द गेट पेपर, सो यू कैन गो फॉर 2 year सब्सक्रिप्शन. क्योंकि सेकेंड और थर्ड ईयर के जो सब्जेक्ट्स हैं कोर टेक्निकल सब्जेक्ट्स, दोज आर इंक्लूडेड इन द गेट सिलेबस. So if you have thoroughly covered those subjects, you need not to put in extra efforts. Anyhow, second or third year में semester exams तो देनी है. So you need not to put in extra efforts for scoring good in the semester exams. Semester exams में आप बहुत अच्छे से qualify कर सकते हो, बहुत अच्छे से स्कोर कर सकते हो. सेकेंड थिंग इज इन द थर्ड ईयर ऑल्सो यू कैन राइट द गेट पेपर. सो गिव योर 100%. अगर आपने अपनी प्रिपरेशन फर्स्ट ईयर सेकेंड ईयर में शुरू किया तो बाय द एंड ऑफ थर्ड ईयर आपकी प्रिपरेशन बहुत अच्छे से हो जाएगी. और 2 years का जो टाइम होता है बच्चे काफ़ी ज़्यादा होता है फॉर द प्रैक्टिस. सो ईजिली यू कैन स्कोर वेल इन द गेट एग्जाम. बाय एनी चांस there is things are not going in your favor, then in that case you will be having one more chances तो आपके पास unlimited है. but here the main advantage is fourth year तो anyhow आपको complete करने ही करने. so without dropping an year again you can write the gate paper to improve your gate score. And in case if you are interested in the placements, you can include your gate score in your resume so that it gets shortlisted, and then you have to go through the mandatory rounds of the placement. First one is the written round, which contains the multiple choice questions from technical and non-technical portion. Coding round, कुछ companies में नहीं भी होते, and definitely you have to go through the technical and the non-technical interview round. So what all subjects you need to prepare for the placements? The first one is the data structures and programming. Very very important. तीनों rounds में आपको data structures और programming में से आप questions expect कर सकते हो. Next one is algorithms. Next one is DBMS, specifically focus on the queries. रिटन में आपके पास मल्टीपल चॉइस क्वेश्चन कंप्यूटर नेटवर्क्स और ऑपरेटिंग सिस्टम्स में भी आ सकते हैं, प्लस एप्टीट्यूड. सो ऑल दीज सब्जेक्ट्स आर इम्पॉर्टेंट फॉर प्लेसमेंट्स पॉइंट ऑफ व्यू. एंड इफ वी टॉक अबाउट the syllabus of GATE, so all these subjects are included in the GATE syllabus. तो अगर आपने GATE की प्रिपरेशन किया तो आपकी प्लेसमेंट्स की प्रिपरेशन ऑटोमेटिकली हो जाएगी. एंड इफ यू आर टारगेटिंग ऑन PSUs then also you need not to put in extra efforts. अगर आपने थॉरोली गेट की आपकी प्रिपरेशन बहुत अच्छे से हो चुकी है तो इन सब में आपको बेनिफिट मिलेगा. मोर ओवर मेनी PSUs आर डायरेक्टली रिक्रूटिंग ऑन द बेसिस ऑफ गेट स्कोर, तो यू नीड टू हैव अ गुड गेट स्कोर. सो इट्स बेटर आइडिया इज टू स्टार्ट योर प्रिपरेशन एज अर्ली एज पॉसिबल सो दैट कि आपको इनफ टाइम मिल जाए प्रैक्टिस के लिए, और जितनी बेटर तरीके से आप प्रैक्टिस करोगे उतना बेटर स्कोर कर पाओगे. राइट. हाय, गुड मॉर्निंग शेख. All right, and this 1 year subscription is for 4th year students and those are pass outs. But if you want to join the crash course and like 2 months to go or थोड़ी सी आपको अगर post gate guidance चाहिए, in that case you can go for 3 months plan. So this is about the plus subscription plans. We have 1 month which is for 4950, 3 months is for 12,375, 6 months is for 22,275, 1 year is for 27 to 25. 18 months के लिए you have to pay 34,650, and for 2 years instead of paying 44,000 you just have to pay 39,600. Okay, so these plans are beneficial for those students, those who have already covered some subjects, they want to cover few subjects as well as they want to revise the remaining subjects. So this is basically for the students, those who want to revise the concepts, they want to get to know about the tricks and crash course. So in that case you can go for 1 month, 3 months or 6 months subscription. If you want to start your preparation from the scratch and you want to cover all the subjects in detail, then you can go for 1 year, 18 months or 2 year subscription. And don't forget to apply the referral code. These are the prices after applying the referral code. So this is after 10% discount. Clear? So this is about the introduction part. In case you want to get to know more about the subscription plans or the referral code, in that case you can fill out the feedback form, and the link of the feedback form is given in the description box. And whatever query you have, you can write your query in that link. All right. So shall we start with the session? As you know that the agenda is counters. Very, very important topic. One of the most important topic from digital logics. Is this clear? Shall we start with the session? Quickly give me a confirmation. Okay, so a topic is counters. Basically counters are nothing but these are used to count, basic application के to count the number of clock pulses. Counters, digital counters design कैसे होते हैं? These contains the number of flip-flops. And we have also talked about the registers. Registers are nothing but where the flip-flops are connected in a cascading manner. It can be connected in the serial manner or the parallel. So there are few registers like the shift registers. Those are providing the base for the ring counter. So that is a type of counter. Basically अगर हम नाम की बात करते हैं कि counters की main functionality के, so their main function is to count the number of clock pulses. और counters design कैसे होते हैं? It contains the number of flip-flops. So basically the basic unit of a counter is flip-flop. We have covered the concept of flip-flops in detail. I hope that there is no doubt in the concept of flip-flops. Right? So the first and the basic point is digital counters consist of a number of flip-flops. Their function is to count the number of clock pulses arriving at its clock input. Now, if we talk about the types of counters, basically on the basis of the clock pulse, counters are categorized into 2 categories. These are categorized into 2 categories. One is known as asynchronous counters and other one is known as synchronous counters. Now, what do you understand by the term synchronous? Synchronous means that which are synchronized. This means that all the flip-flops are clocked simultaneously. जैसे आपके पास clock apply होगी, all the flip-flops will be working together. So synchronous counters means all the flip-flops are clocked simultaneously. Asynchronous is reverse of synchronous. This means that all the flip-flops are not synchronized simultaneously. तो asynchronous के केस में क्या होता है, जो आपके पास clock pulse है, that is provided, the input clock is provided to one of the flip-flop, and remaining flip-flops will be getting the clock on the basis of the output of the previous flip-flop. So asynchronous counters are nothing but flip-flops which are not clocked simultaneously. Here each flip-flop is triggered by the previous flip-flop. That is the basic functionality. We have special types of counters, special types of synchronous counters which are known as the ring counters. Okay, so in this we have to discuss special types of synchronous counters which are known as the ring counter, and ring counters are further categorized into two categories. One is known as the basic ring counter and other one is known as the twisted ring counter. These are further categorized into two categories: basic ring counter and twisted ring counter. Twisted ring counters are also known as Johnson counter, walking counter, creeping counter, and so on. Lot many names are there. Correct? So we'll start our discussion with the synchronous counters. We will be talking about the ring counters, that is the basic ring counter, twisted ring counter, series synchronous counter, and after that we'll learn that how to design the synchronous counter. Then we'll move on to the asynchronous counters. In asynchronous we'll be talking about the up counter, down counter, designing of asynchronous counter, and that's it. So this will be the agenda for today's session, and whatever previous year questions has been asked on the basis of this, for that we will be having a separate session named as previous year questions on counters, or practice session on counters. All right. Any doubt till this point? So first one is how to use shift registers as counters. So one of the basic application of shift register is that they can be arranged to form a ring counters. तो कौन से registers use होते हैं? We have talked about serial in, serial out, serial in, parallel out registers, parallel in, serial out, and parallel in, parallel out. So in this particular case, serial in, serial out registers are modified, are used as the counters. So one of the application of shift register is that they can be arranged to form a ring counter. Ring counters are nothing but these are special types of synchronous counters. Ring counters are constructed by modifying the serial in, serial out shift registers. So this can be asked in 1 mark that which of the following register is used to construct the ring counters? It's serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So clearly the answer is serial in, serial out. Now we have already talked about types of ring counters. These are basic ring counters and twisted ring counter. Twisted ring counter is also known as Johnson counter, switch tail counter, movies counter, creeping counter, or walking counter. So what is the difference? Let's talk about the difference, and we'll also talk about the number of used states and number of unused states in each of the counter. Okay, so if we have to construct a counter using 3 flip-flops, then total how many states are possible? Can you identify the number of states? Good morning, Harsha. If n flip-flops I'm using here, okay, if n flip-flops are used, let's assume that I'm taking 3 flip-flops. This is flip-flop 1, this is flip-flop 2, This is flip-flop 3. Every flip-flop is having two outputs, Q0, Q1, Q0 complement. This is Q1, Q1 complement. So how many combinations are possible? Q2, Q2 complement. Take anything. 3 flip-flops are connected. Synchronous means same clock pulse. All the flip-flops are clocked with the same clock pulse. So how many combinations are possible? Output कितने bits की आएगी? It will be Q0, Q1 and Q2. So how many combinations are possible with 3 bits or 3 flip-flops? Total number of states. Because if they are asking for the number of unused state, for that you should know the total number of states, number of used states. Subtract करोगे तो आपके पास number of unused states आ जाएगा. So total number of states कितनी हो सकती हैं? With 3 inputs, how many combinations are possible? It is 8 combinations. If I'll be using 4 flip-flops, then the number of combinations or different number of states, total number of states possible will be 2 raised to power 4. If n flip-flops are used, तो maximum number of states कितनी हो सकती है? Maximum number of states can be 2 raised to power n. Right? If you are using 3 flip-flops, you can represent up to how many states? 8 states. This means that if n represents the number of states, this should be less than or equal to the total number of states. यहाँ पे n क्या represent कर रहे हैं? n is representing, small n is representing the number of flip-flops. Because whenever we have to design a flip-flop, first of all we have to design a counter. First of all, we need to identify that how many flip-flops will be used in the design. So that can be identified on the basis of the number of states. Very good morning, Shweta. Okay, and what capital N is representing here? Capital N represents the states. Okay. Now, I want to construct a ring counter. Ring counter or Johnson ring counter में जो difference है, this is serial in, serial out. We have already discussed the serial in, serial out register. So let's consider 4-bit counter. 4-bit ring counter. 4-bit का मतलब क्या? Need to take 4 flip-flops. I'm taking 4D flip-flops. Delayed flip-flops. Delayed D3, D2, D1, D0. Every flip-flop will be having 2 outputs, one which are complement of each other. Let's say that this is Q3, then this will be Q3 complement. This is Q2, this will be Q2 complement. This is Q1, Q1 complement, Q0 and Q0 complement. Since this is a special type of synchronous counter, so all the flip-flops will be clocked simultaneously. All the flip-flops will be clocked simultaneously. This is the clock applied. What about the serial in, serial out? इसका मतलब क्या है? Input will be provided from one end. Let's assume that this is some input and the output of the previous one becomes the input for the next one, for the next one, for the next one. In case of ring counter, the output of the last flip-flop will be connected with will be behaving as the input for the first flip-flop. So this means that feedback, this is the feedback. Feedback is given with uncomplimentary output. Complementary output. जॉनसन रिंग और ट्विस्टेड में क्या हो जाता है? यहाँ पे जो आपके पास अनकॉम्प्लीमेंट्री के साथ फीडबैक गिवन है, ट्विस्टेड में इट विल बी प्रोवाइडेड विद अ कॉम्प्लीमेंट्री आउटपुट. That is the difference between the ring counter and the Johnson ring counter. Yahan tak clear? What is this Unacademy? Now on the basis of this, we have to identify the output. So initially, let's assume that no clock is applied. No clock is applied. So that is 0. So what is the output present? That is Q3, Q2, Q1 and Q0. What is the output available at Q0? It is 0. In case if you're not going to provide any input here, then it will take what? The output is here, it is set as 0. Q2 is providing, the value of Q2 is 0, the value of Q1 is 0, the value of Q0 is 0. Now if I set the input, बच्चे synchronous counters को execute करने का तरीका क्या होता है? First of all, set the input for all the flip-flops, जो भी connections है, set the input, apply the clock pulse, note down the output, right? So first step is to set the input. Set the input. In order to execute any synchronous counter, first of all, I need to set the input. What will be the input for D3? यहाँ पे कुछ भी input नहीं है. It keeps on rotating the values of 0. So this is not getting any other value. So we need to introduce some value. Let's assume that the input is 1. Input is 1. What will be the input here? This is the starting state. So what will be the input here? The output of the previous flip-flop, that is Q3. This is 0. Set the input, it will be 0. Set the input, output is 0. So this will set as the input. Now apply the clock pulse. First clock is applied. What will be the output? This is a delay flip-flop. So if the value is 1, so it will be updating the value 1. If the input is 0, output will be 0. If the input is 0, then the output will be 0. If the input is 0, output will be 0. So what output we are getting? We are getting 1, 0, 0 and 0. We got 1, 0, 0. For the next clock, again, first of all, you need to set the inputs. Now, what will be the input here? Whatever is the output you are getting here. What output you are getting here? It is 0. So this 0 will be the input for the next clock. यहाँ पे D2 के लिए input क्या आएगी? Whatever is the previous output. D1 के लिए what will be the input? Whatever is the output of the previous one. It comes out to be 0. यहाँ पे input क्या होगी? It will be 0. Now apply the clock pulse. Input is 0, so it will be producing the output 0. Input is 1, it will be producing the output 1. Input is 0, it will be producing the output 0. Input is 0, output will be 0. So what output we are getting? We are getting 0, 1, 0 and 0. 0, 1, 0 and 0. Second clock. Ma'am, by default, every flip-flop is having 0 as input. So definitely it will get 0 as the output. Definitely. So in this case, it needs to be started. Ring counters जो होते हैं आपके पास, that can be self-starting. Right? Next. Again set the input. जो भी आपके पास Q0 से output आ रही है, that will be the input for Q3. So here you will be getting 0. Here you will be whatever is the output for Q3, that will be the input for the Q2. That comes out to be 0. This comes out to be 1 and this comes out to be 0. This is again different state. Next, again apply the clock pulse. Whatever is the output, basically how is this working? If you have the serial in serial out register, it is 1 0 0 0. So the output you are getting from here, it becomes the input for the first one. Yes, you can choose it. 111 0 000 is not possible because in this case we have taken only 4 flip-flops. So maximum जो आपके पास bits होंगी, that will be 4. You can't take 5 inputs, 5 bits. Clear? You can choose any input. I have just taken this as 1000. You can take anything with 4 bits. Next, यहाँ पे change क्या आएगा? 0 becomes the input for D3. Q3 becomes the input for D2. Input for the next. This is the next one. Now go for the next clock. Now what will happen? This comes here 0, 0, 0. If you look at the state, this is the repeated one as that of 1. So how many clocks are used? This is 4 clocks. Basically counters are counting the clock cycles. So how many clock cycles are applied here? This is 4. So how many states are used? With 4 bits, we know that 2 raised to power 4, 16 combinations are possible, but instead of using 16 combinations, it's just using 4. Ma'am, why this one changing to 0? See, it's not changing to 0, just we are shifting the bits. In the first clock, if it is 1, जब आप second clock apply करोगे, this is serial in, serial out. तो जो भी आपके पास first flip flop की output है, that will become the input for the second one. If the output here is 0, first वाला clear हुआ था आपको? First of all, let me know that if the first clock cycle is applied properly. बच्चे यहाँ पे हम input set कर रहे हैं. See, if the input was set as 1, first of all, you have to set the input. Second step is to apply the clock pulse. Apply the clock pulse. And then you have to note down the output. Down the output. So if the input is taken as 1000, तो first case में आपके पास input is taken as 10, so the here it is 1, it is 0, it is 0 and it is 0. Okay, some input is taken with 4 bits. You can take any input. It's not the mandatory case that every time you have to take it as 1000. Take any input of 4 bits. Okay, so input is taken as 1000. So this means that the value of D3 is 1, D2 is 0, D1 is 0, D0 is 0. Now second step is to apply the clock pulse. जैसे आपने clock pulse apply की, these flip flops will be working and they will be producing some output. For the D flip flop, if the input is 1, what will be the output? It will be 1. Then after that shifting happening, but how you did for clock 1? Because after clock 1, it is shifting. See, first clock के लिए I have set the input. जैसी first clock apply हुई, what output we are getting? We are getting the output as 1000. Right? So I have noted down the outputs. Output for the value of Q3 is 1, the value of Q2 is 0, the value of Q1 is 0, the value of Q0 is 0. Yes, I'm taking 1000 as example. ये example क्यों consider किए? Why I'm taking 4 bits? Because we have 4 flip flops. And why I'm considering this example? Because I have to count the states. You can take this as 1100. You can take this as 1001. Anything you can take. It doesn't matter what input you are taking because this is serial in, serial out. Whatever input you are taking, it's just shifting the bits. Clear? Yes, this is just an example. So now first clock के बाद we have noted down the output. So this is the output. Now for the second clock, let me change the ink color. For second clock, I am taking the green color. For the second clock, before applying the clock, you have to set the input. Now what will be the input for D3? अब दोबारा से आप कोई भी example consider नहीं करोगे. D3 के लिए input के it is getting the value from Q0. What is the output at Q0? That is 0. So input is set as 0. Q3 is behaving as the input for D2. What is the value of Q3? That is 1. So input is set as 1. Input is set as 0. Output you got here 0. So input is 0. Now apply the clock pulse. Second step. Apply the second clock. जब second clock apply करोगे, whatever input is available here, that will be the output. Input is 1. Output will be 1. Input is 0, output will be 0. Input is 0, output will be 0. Note down the outputs. It's 0, 1, 0, 0. So we got the output as 0, 1, 0, 0. Again, after noting down the output, again set the input. In ring counter, we can use any register. Usually this is just shifting the value. It is not modifying any value. So that's why I have used the delayed flip-flop. If you want to implement this with the help of JK flip-flop, तो J की value हमेशा क्या रहेगी? It will be the 1. Because JK flip-flop is the universal flip-flop, so with the help of JK flip-flop, you can implement this. Alright, but usually this is taken as the delayed flip-flop because it has to return the same bits. So how many states are used here? Number of states, number of used states. Number of used states are what? बच्चे मैंने इसी का आंसर दिए. No, parallel in, parallel out is not possible because in that case you are not shifting the bits. This is the shift register. Either it will be shifting the bits towards the left or towards the right. Parallel in, parallel out में क्या होता है? Parallel it is giving you the output. Starting में only I have discussed that. In the beginning only I have discussed that ring counters are constructed by modifying serial in, serial out registers. So obviously बात है कि आप कोई भी और register use नहीं कर पाओगे because serial in, serial out behaves as the shift register. This can be asked in 1 mark. So your question के लिए जो आपका question है बच्चे उसके लिए answer is no. So how many clocks we have applied here? यहाँ पे कोई clock तो apply की नहीं है. This is not applied. This is the default case. So how many clocks we have applied? It's 1, 2, 3 and 4. So how many states are used? That is 4 states are used. So number of used states are 4. With 4 flip-flops, total number of states possible are 16. That is 2 raised to power 4. So number of unused states will be equal to what? Total number of states with 4 flip-flops, 2 raised to power 4 states are possible minus 4. So these are the number of unused states. So if you have to written in the general, if n bit ring counter is there, for n bit ring counter, number of used states are is equal to n, and number of unused states is equal to total possible states are 2 raised to power n minus n. Yes? So number of unused states are total states minus the used states. So this is the example and this is the general formula. Clear? This is all about ring counter. Any doubt in the ring counter? This is the basic ring counter or the ring counter where the feedback is given with uncomplimentary output. With uncomplimentary output. Next, we have to talk about the Johnson ring counter, or which is also known as the twisted ring counter. In twisted ring counter, the feedback is given with a complementary output. Johnson ring counter, feedback is given with the complementary output. This is the only difference. So let's take 4-bit counter. I'm taking 4 delayed flip-flops. Just हम यहाँ पे feedback को change करेंगे. This is D3. This is D flip-flop. This is also D flip-flop. This is also D flip-flop. So outputs are, let's assume Q3, Q3 complement, Q2, Q2 complement, Q1, Q1 complement, Q0, Q0 complement. Feedback is given with, this is a shift register, serial in, serial out. So input, these are connected. This is serial in, serial out. But यहाँ पे feedback is given with the complementary output. So complementary output is here. Feedback is given with the complementary output. Synchronous counter है. So same clock is applied. Clock, clock, clock. In this, I have to find out the number of used states in the Johnson ring counter. Can you return the number of used states? Let's assume that at 0, clock, output is Q3, Q2, Q1, Q0. So if the initially output is 0, यहाँ पे हमें default value consider करने की जरूरत है. Do we need to consider the default value? No. Reason is, if the output is 0 here, if this is 0, Q0 का complement is Q0 complement. So if Q0 is 0, what will be Q0 complement? It will be 1. So 1 is the input for D3. The very first step is to set the input. So for D3, input will be 1. For D2, input will be 0. For D1, input will be 0. For Q1 becomes the input for D0. Inputs are set. First cycle में कोई doubt? बच्चे यहाँ पे मैंने example consider नहीं किए. Initially, if all the outputs are 0, then by default, it comes out to be 1,000 input. Now, apply the first clock. Input set कर ली, apply the first clock. What will be the output? Output becomes 1. Output becomes 0. Output becomes 0. And output is 0. So this comes out to be, after applying the first clock pulse, we are getting the output as 1,000. Again, set the input. 1,000. Again, set the input. If the output at Q0 you are getting 0, then the Q0 complement will be 1 again. So again, the output comes out to be 1. This output becomes the input for D2, 1. This comes out to be 0. This comes out to be 0. Basically, easy way में evaluate करने के लिए you can consider this as if we have Q3, this is Q3, 0, 0, 0, 0. We had Q2, Q1, Q0. यहाँ पे जो आपके पास Q3 के लिए input है, what is that value? That is the complement of Q0. That is the not of Q0. Not of Q0. Shift register. So not Q0 is what? 0. Q0 of not will become 1. So you will be getting here 1 triple 0 after the first clock. Second clock के बाद क्या होगा? Q0 is what? That is nothing but 0. So Q0 का complement is giving the value for Q3. So Q0 का complement is 1. This will be shifted here. This will be shifted here. This will be shifted here. Again Q0 is 0. So its complement is 1. This comes out to be 1. This will be shifted here. This will be shifted here. This will be shifted here. So this way you can note down the outputs for all the clocks. So this comes out to be 1, 1, 0, 0. Third में again this comes out to be, you have to take the complement of Q0, 1, shift the remaining bits. Fourth, this is 0. So again you will be getting here 1. Should I stop here? No. Repetition अभी शुरू नहीं हुई है 5 के लिए. Here we are getting 1 now. So if it is 1, if this is 1, then the complement will be 0. So this means that here you will be getting the input as 0. So it will be producing the output as 0. Shift the remaining bits. Following this concept. So again, here we have 1. So this comes out to be 0. Shift the remaining bits. Again 1. So here you will be getting 0. Shift, shift and shift. 7. For 8. Again we are getting here 1, 0, 0, 0 and this is shifted 0. If I'll take here 9, अगर आप 1 से check कर रहे हो, if I'll be taking here 9, so 0 means here you will be getting 1, 0, 0. Again repetition is starting. So this comes out to be 1 to 8. So how many states are there? It's 1 to 8. How are you getting this value? Ma'am, repeat clock 3 please. Clock 3. बच्चे मुझे ये बताओ, ये आपको समझ में आए? Basically Q3 की जो आपको value मिल रही है, what is that value? That is nothing but in the next cycle, that is the Q0 complement. Q3 की जो value है, what is that value? That is the Q0 here. From here you will be getting the Q0. It's the complement of Q0. Right? तो अगर आपके पास Q0 की value 0 है, तो Q3 की value next cycle में क्या होगी? It will be 1. आप set भी कर सकते हो. Q2 में आपके पास outputs क्या हैं? It is 1, 1, 0, 0. Output is 1, 1, 0 and 0. If this is the output, तो अगर Q0 की value 0 है, तो Q0 complement की value क्या होगी? It will be 1. So 1 will become the input for D3. Yes, this is output as 1. So here you will be getting the input as 1. Input set कर रहे हैं, output as 1. So here the input will be 1. If the output is 0, input will be 0. So what, apply the clock pulse, what will be the output? Output will be 1, output will be 1, output will be 1 and output will be 0. 2 raised to power 8. बच्चे मैंने तो यहाँ पे 4, I have taken here 4 flip flops. हर एक flip flop में आपके पास एक ही bit जा रही है, तो total आपके पास 4 bits है. With 4 bits, how can you get 256 combinations? 4 bits के साथ maximum combinations कितने बन सकते हैं? 1 bit If 4 bits are there, एक bit की value क्या हो सकती है? It can be 0 or 1. This can be 0 or 1. This can be 0 or 1. This can be 0 or 1. Two ways are there to fill this position. Two ways to fill this position. Two ways, two ways. So this comes out to be 2 raised to power 4. बच्चे 4 bits के साथ आपके पास 2 raised to power 4 combinations बनते हैं. पूरा डिजिटल खत्म हो चुका है हमारा. So total possible states with 4 flip-flops will be 2 raised to power 4. But used कितनी हो रही है? 8. So used states are 8 here. Total states are 2 raised to power 4 because with 4 flip-flops total states will be 2. But there's a difference between the clock pulses and the number of states. कितनी states represent कर सकते हो आप? Clock pulse तो अगर आपके पास कोई loop बन रहा है तो clock pulse तो आप apply करते जाओगे, but different states कितनी आ रही हैं? Even here I have applied the 9th clock. Clock तो apply किए तो clock पे तो हमने stop नहीं किए. हमने यहाँ पे stop क्यों किए? Because this state is repeated. Why we have stopped at clock number 8? Because 9 से again repetition is going to start. So with 4 flip-flops, total states possible are 2 raised to power 4. तो unused कितनी होंगी? Unused will be 2 raised to power 4 minus 8. In general, we can say that if n bit flip-flop is there, then the used states will be 2 into n. Right? In the previous case, in the basic ring counter, number of used states were n. In the case of Johnson ring counter, used states are 2 raised to power n. So the unused states will be 2 raised to power n. These are the total states. बच्चे आपके पास synchronous counter है, asynchronous counter है, Johnson ring counter है, basic ring counter है, ring counter. Anything is there. If n flip-flops are there, maximum states, maximum combinations कितने हो सकते हैं? That is 2 raised to power n. These are the total possible combinations. But used are here, how many combinations are used? That is just 2 into n. So this represents the number of unused states. So on the basis of this, you can get a direct question on the basis of the number of used states or unused states. Numerical answer type question आ सकते हैं. आपको flip-flops given होंगे and you have to return. You have to enter your answer as whatever they have asked in the question. Is this clear? Any doubt? So this is about the special types of synchronous counters, ring counter and the Johnson ring counter. Let's move on to synchronous series counter. अब यहाँ पे जरूरी नहीं है कि आपके पास shift register ही use होगा. So any register or any combination can be taken. So let's consider one counter and for this we have to determine the output. आपके पास question कैसा आएगा? They'll give you some counter and they'll say that how many states would be there, or they can also ask for the sequence of the output. Okay, up to 4 clocks, up to 7 clocks, up to 10 clocks or something like that. So let's talk about the synchronous series counter. I'm taking a counter with the T flip-flop. T flip-flop I'm using here. So that is T0, Q0, Q0 complement. T1, Q1, Q1 complement. here I'm taking 4 flip-flops. So how many total states can be there? Write in the comment section. T3, Q3, Q3, complement. Since this is a synchronous counter, clock. Now the output is input for the first one is 1, and here we are having the AND gate, and this is 1. Okay, so let's assume that Q3 is the most significant bit and this is the least significant bit. What will be the output? How many states would be there? Yes, total states possible are 16 because here we have 4 flip-flops. Now one by one you have to apply the clock. बच्चे अगर आप क्लॉक्स को अप्लाई करते जाओगे तो काफी टाइम लग जाता है. इसके लिए शॉर्ट तरीका क्या है कि आप पहले पैटर्न को ऑब्जर्व करो कि कौन से इनपुट कौन सा फ्लिप फ्लॉप का वैल्यू को चेंज कर रहे हैं. ओके, सो इन दिस केस इफ यू ऑब्जर्व दैट जो आपके पास लीस्ट सिग्निफिकेंट बिट है, so if I'm writing the outputs, let's mention here the clocks. Output is Q0 is representing, this is representing the least significant bit. So most significant bit is Q3. So let me write here Q3, Q2, Q1 and Q0. एग्जाम में आपको इस चीज पे जरूर ध्यान देना है कि whether which flip flop is giving you the most significant bit and which one is giving you the least significant bit. So here Q0 is the least significant bit. हमेशा जो आपके पास flip flop 0 है, let me call this as flip flop 0. Flip flop 0. This is flip flop 1. This is flip flop 2. This is flip flop 3. मैंने कुछ naming दिए just to refer this. So every time, since this is a toggle flip flop and this is connected with the input 1, तो इसका मतलब क्या है? जो आपके पास flip flop 0 है, that will always toggle. फ्लिप फ्लॉप 0 टॉगल करेगा मींस हमेशा Q0 की वैल्यू हर एक सब्सिक्वेंट साइकिल में इट विल टॉगल. टॉगल T की वैल्यू इफ इट इज 1, तो अगर आपके पास प्रीवियस आउटपुट 0 है, देन इन द नेक्स्ट केस यू विल बी गेटिंग द आउटपुट एज 1. इफ द प्रीवियस आउटपुट इज 1, इन द नेक्स्ट केस यू विल बी गेटिंग द आउटपुट एज 0. मेक सेंस? नाउ हियर इफ फॉर क्लॉक 0 इनपुट्स आर 0, तो Q0 की वैल्यू हमेशा टॉगल करेगी. T1 की वैल्यू किस पे डिपेंड कर रही है? ऑन द आउटपुट ऑफ Q0. सो T1, Q1 विल टॉगल, Q1 टॉगल्स. Q1 कब टॉगल करेगा? जब T1 की वैल्यू 1 होगी. और T1 की वैल्यू 1 कब होगी? when Q0 is 1. Q1 toggles when Q0 is equal to 1. Q0 is equal to 1 and clock is applied. Clock तो सब में apply करनी है to change the output. T2 flip flop 2 कब work करेगा? When the clock is applied as well as the value of T2 is 1. T2 की value कब 1 होगी? Q2 will toggle. Q2 कब toggle करेगा? When T2 is 1. T2 1 कब होगा? This is the AND gate. We want the output here 1. 1 कब आएगा? When Q1 and Q0 both are 1. ये वीडियो लेक्चर डिलीट तो नहीं होंगे YouTube से? नहीं, ये लेक्चर्स डिलीट नहीं होंगे. राइट? सो Q2 की वैल्यू कब टॉगल करेगी? जब T2 की वैल्यू 1 होगी, और T2 की वैल्यू 1 कब होगी? when Q0 and Q1 are 1. So basically Q2 will toggle when Q0 is equal to Q1 is equal to 1. ये हम क्यों ऑब्जर्व करें? सो दैट कि हम स्पीडली आउटपुट्स डिटरमाइन कर पाए. T3 कब टॉगल करेगा? Q3 will toggle, Q3 toggles when, जब वैल्यू 1 होगी T3 की वैल्यू 1 कब होगी? when the output from here is 1. यहां से 1 कब आएगा? जब Q0 and Q1 दोनों 1 है, and Q2 needs to be 1. This means that Q3 will toggle when Q0, Q1 and Q2 are 1. Is this clear? Because if this clear, then easily we can construct the truth table. This is one approach of attempting such type of questions. Other approach is set the input, every time calculate the values, and then apply the clock pulse, note down the output. So we have written those steps, but definitely it will consume a lot of time. So let's quickly apply the clocks. First clock apply करनी है. Q0 तो हमेशा ही टॉगल करेगा. It will toggle. Q0 की वैल्यू जब 1 है तो उस टाइम पे Q1 क्या करेगा? If that is in the next case. अभी के लिए previously what inputs are set, in the previous case Q0 was 0. If Q0 is 0 तो next cycle में आपके पास वैल्यू सेट नहीं हुई है. So it is 0, 0 and 0. Right? बच्चे हर वैल्यू पुट करनी ही नहीं है. Moreover, this is not behaving as XOR. I am taking here 2 AND gates, not behaving as XOR. I won't suggest you to cram anything. जहां पे आपको शॉर्टकट ध्यान में रखना है, I'll let you know that you can cram this thing or you can keep this point in mind. This is just I have considered an example. तो यहाँ पे आपके पास कुछ भी सर्किट डायग्राम हो सकता है. Now here Q0 is 1. Q0 तो हमेशा ही टॉगल करेगा. In the second clock, obviously this will toggle. Second clock में Q1 कब टॉगल करेगा? जब previous केस में Q0 was 1. Q0 is equal to 1, then Q1 will toggle. So Q1 will toggle. Q1 की वैल्यू टॉगल होगी. Q2 कब टॉगल करेगा? जब दोनों की वैल्यू 1 थी, but it was not 1, so it won't toggle. So this is the output for the next clock. For the next clock, Q0 will toggle. Q0 ने टॉगल किया. Q1 कब टॉगल करेगा? जब Q0 की वैल्यू 1 थी, but Q0 was not 1, so the output remains the same. Q2 कब टॉगल करेगा? When Q0 and Q1 both were 1. Both were not 1. So Q2 remains the same. Q3 remains the same. Now in the fourth clock, Q0 will toggle. It comes out to be 0. Q1 toggle करेगा. Q0 की वैल्यू was 1. So definitely Q1 will toggle. Both were 1. So Q2 will toggle. तीनों 1 नहीं है, so Q3 will not toggle. Please repeat clock 3. Okay. For this clock, here, let me change the ink color. Here, the value of Q0 was 0. Right? तो Q1 toggle नहीं करेगा. Q1 कब toggle करेगा? When the value of Q0 is 1. But the value of Q0 is what? The value of Q0 is 0. Right? So it will not toggle. Whatever value it is containing, it remains the same. Clear? Q2 will toggle when the value of Q0 and Q1 both are 1, but it's not 1, so it remains the same. All the three values are not 1, so it remains the same. Similarly, for the fourth clock, value is 1. Q0 ने तो toggle करना ही है, so it has toggled. Value is 1, so this value has toggled. Both the values are 1, so this has toggled. Three values Q2, Q1 and Q0 तीनों 1 चाहिए, तीनों 1 नहीं है, so this is not toggled. This is the output after fourth clock. After the fifth clock, बच्चे मैंने इस सर्किट डायग्राम की समरी लिख लिया यहाँ पे एंड अकॉर्डिंगली आई एम राइटिंग डाउन द आउटपुट्स. ओके, तो इसको क्रैम नहीं करने कि हमेशा यही होगा. इट इज डिपेंडेंट ऑन दिस सर्किट डायग्राम, ऑन दिस काउंटर. Now in this case, Q0 will toggle. Yes, we can design the counters. I'll be going to the designing of counters in the next slide. Let's discuss this, how to note down the output, and after that we'll move on to the design of synchronous counters. And I'll be taking 2 to 3 examples with different flip-flops. D flip-flop, T flip-flop, JK flip-flop and so on. Okay. So the value is toggled here. This value is 0, so this value won't toggle. Toggle नहीं करेगी तो value remains the same. Value remains the same. Value remains the same. For the sixth clock, value will toggle. Value toggles. Value is 1, so it will toggle. Value, both the values are not 1, so it won't toggle. It won't toggle. Continue with this. This is clock Q3, Q2, Q1 and Q0. For the next clock, 7th, the value is 0, so it comes out to be 1. It has to toggle in every clock. Value is 0 here, so Q1 will not toggle. Value of both the values are not 1, so it will not toggle. Values तीनों की 1 नहीं है, so it won't toggle. Similarly, note down the outputs for clock 8. Value is 1, so it will be toggled to 0. Value is 1, so this value will be toggled. Both the values are 1, so it will be toggled. All the three values are 1, so for the first time it is toggling its value. Clear? Next clock, 9. This value will toggle. The previous value was 0, so it won't toggle. Both the values, अगर एक भी 0 आ गया तो बाकी सारे as it is रहेंगे. For the 10th clock, 0 to 7 तक जाना है. क्यों 7 तक जाना है 0 से? But here we have 4 flip-flops. This means that 4 bits starting from 0 to flip-flop 3. बच्चे अपने आप स्टॉप नहीं करने. हम कब तक नोट करेंगे? जब तक रेपिटेशन शुरू नहीं हो जाती या फिर मैक्सिमम स्टेट्स तक नहीं पहुंच जाता. Okay. So here it will toggle its value. Value was 1, so it will toggle its value. Yes, it is 4-bit. Value is 1, so it has toggled its value. Both the values are not 1, so it won't toggle. All the three values are not 1, so it won't toggle. For 11, this will toggle. The value is 0, it won't toggle. It won't toggle and it won't toggle. For 12, value will toggle. For Q0, Q0 will toggle. The value is 1, so it will toggle. Both the values were 1, so it will toggle. All the three values are not 1, so it won't toggle. It remains the same. For 13, this value will toggle 0 to 1. The previous value is 0, so it won't toggle. It won't toggle. For 14, toggle. Value is 1, so it will toggle. These will not toggle. For 15, this will toggle. Value was 0, so it won't toggle. So maximum state 0 to 15 आ गए. अगर आप 16th clock apply करोगे, what will happen? This will toggle. Value is 1, so again it will toggle. Both the values are 1, it will toggle. all the three values are 1, it will toggle. So again you are getting the first state. या तो आप 1 to 16 consider कर लो और 0 to 15 consider कर लो. So this is repeated. So how many different states are there? It is 2 raised to power 4, that is equal to 16. मैम सीक्वेंस कौन सा बन गया 0 to 16 क्लॉक पल्स में? You can observe the sequence. It's 0, 1, 2, 3, 4, 5. This is up counter. This is behaving as the up counter. Series में आपके पास values up direction में जा रही हैं 0, 1, 2, 3, 4. This is the binary of 0. This is the binary of 1, binary of 2, binary of 3, binary of 4, 5, 6 and so on. So total 16 clock pulses are required to represent 16 combinations. बच्चे अगर आप इस combination को count नहीं कर रहे हो, you are counting this, then this is the different combination. So it's 1 to 16. अगर आप if you are counting from here, then it's 0 to 15. So 16 clock pulses are used. Clear? This is synchronous series counter. So one thing is very much sure that all the flip-flops are applied with a common clock. और आउटपुट जनरेट करने के लिए आपको कोई भी काउंटर गिवन है, आउटपुट जनरेट करने के लिए तरीका क्या है? फर्स्ट ऑफ ऑल यू नीड टू सेट द इनपुट, अप्लाई द क्लॉक पल्स, सब पे एक साथ क्लॉक अप्लाई होगी, नोट डाउन द आउटपुट ऑफ ऑल द फ्लिप-फ्लॉप्स. राइट? So 0-0 combination is available here. So it's 0 to 15. 0 to 15 means 16. Any doubt till this point? So we have talked about different types of synchronous counters. I hope that this is clear. And on the basis of this, now we will be moving on to the designing of synchronous counters. So I'll be taking different examples with different flip-flops. हमेशा हम T या D use नहीं करेंगे. It can be given in the question that which flip-flop you have to use. So if there is no doubt till this point, quickly give me a confirmation. Everyone? So next we have designing of synchronous counters. So first of all, in the designing of synchronous counters, they'll give you the sequence that what sequence needs to be generated by the counter. Okay, so according to that, first of all you have to determine that how many flip-flops are required. Flip-flops कैसे require? Ma'am, when we will be having gate questions on these topics, we will be having the questions. I'll be taking a previous year question series, questions on these topics in the special classes. Starting from Monday, we will be discussing the previous year questions on these topics. All right? So first of all, जब भी बच्चे आप काउंटर डिजाइन करोगे, फर्स्ट ऑफ ऑल यू नीड टू डिटरमाइन दैट हाउ मेनी फ्लिप फ्लॉप्स आर रिक्वायर्ड. फ्लिप फ्लॉप्स कितने रिक्वायर्ड होंगे, कैसे डिटरमाइन करोगे? फॉर एग्जांपल, इफ आई वांट टू डिजाइन अ काउंटर टू काउंट 5 states, then how many flip flops will you be taking? Harsha, you can attend the sessions on the special class. These are free. तो बच्चे आप YouTube पे अटेंड करो या फिर स्पेशल पे करो, कोई डिफरेंस नहीं है. अब आप बोलोगे कि मैम आप भी तो फिर YouTube पे ले सकते हो जब कोई डिफरेंस ही नहीं है ना? तो बच्चे डिफरेंस ये आता है कि स्पेशल में हमारे पास एक फीचर है पोल का. तो व्हेन आई विल बी डिस्कसिंग द क्वेश्चंस, तो व्हाटएवर क्वेश्चन आई विल बी गिविंग यू, फर्स्ट ऑफ ऑल आई विल आस्क यू टू सॉल्व दैट क्वेश्चन, और जो भी आपका आंसर होगा यू हैव टू एंटर योर आंसर थ्रू द पोल सो दैट आपको भी समझ में आए कि आप कितना क्विकली आंसर रिटर्न कर पा रहे हो एंड कितने लोगों ने सही आंसर दिए, वेयर यू आर स्टैंडिंग. सो दैट इज द प्लस पॉइंट if we are going to have the questionnaire round or the quizzes on the special classes. Anyhow, these are free of cost. अगर आपने अब तक unlock नहीं किए तो आप free plan को unlock कर सकते हो by using the referral code that is my first name. You can use this referral code. Okay. So that's why this is the main reason ki why I want to take the questions on special classes. इसीलिए क्योंकि free रहे इसीलिए I am taking that on special, not on plus. Okay. So if number of states are 5, how many flip-flops are required? But I am asking about the number of states, not about the number of flip-flops. अगर 5 states को represent करना है, 5 states को कितनी bits के साथ represent कर सकते हो? Basically, one flip-flop is returning 1 bit. So if you want to represent 5 combinations, 5 states, how many bits are required? How many flip-flops are required? श्वेता, जरा ध्यान से सोचो कि ये 2 raised to power 5 होना चाहिए. Not getting the response. See, if I want to represent 5 states or 5 combinations, with 2 bits you can represent 4 combinations. With 3 bits you can represent 8 combinations. So 4 is not possible. It is not representing all the states. This means that 3 flip-flops are required, right? Similarly, if I want to represent 10 states, how many flip-flops are required? To represent 5 states, 3 flip-flops are required. To represent 10 states, how many flip-flops are required? With 3 flip-flops, you can represent up to 8 states, 2 raised to power 3. With 4 flip-flops, you can represent up to 16 states. तो उनमें से 10 states आपके पास use हो जाएंगी and remaining 6 states will be the unused states. So this means that 4 flip-flops are required. If I want to represent 32 states, how many flip-flops are required? To represent 32 states, how many flip-flops are required? It is 5 flip-flops. If number of states are given, then you can determine the number of flip-flops. If input sequence is given, for example, 1, 3, 2 and 0. This is the sequence. जो भी आप counter design करोगे, it should generate the sequence. So how many flip-flops are required? How many different sequences are there? There are 4 sequences. 4 means 2 flip-flops are required. Or you can also consider, you can represent this in the bits. 3 को represent करने के लिए you need 2 bits. 0, 1. This is 1, 0. This is 0, 0. So 1 flip-flop, another flip-flop. So basically 2 flip-flops are required. So on the basis of the given input, can you determine the number of required flip-flops? That is the first step. So whenever we have to design a counter, first of all we need to determine the number of required flip-flops. I hope this step is clear to everyone. Ma'am, please repeat the last one. बच्चे, अगर आपको number of sequences ना देके, if they have given that your counter should come up with the output like 1, 3, 2, 0 and again it will go to 1. तो basically कितने sequence आ रहे हैं आपके पास? You are getting here 4 sequences. तो यहाँ से आपको समझ में आ गया, you need 2 flip-flops. Other thing is, if you are going to represent each number using the binary, तो मैक्सिमम नंबर में जितनी बिट्स यूज होंगी, बाकी सबको उससे कम बिट्स के साथ यू कैन रिप्रेजेंट. 3 कैन बी रिटन एज बाइनरी ऑफ 3 इज 1, 1. Binary of 1 is 0, 1. Binary of 2 is 1, 0. Binary of 0 is 0, 0. 0 can be represented as 0. If sequence is 1, 3, 7, then in that case we will be representing it with 3 bits, because 7 cannot be represented with 2 bits. Clear? Because whenever we are dealing with the data, we are always considering the binary bits. So we have to take the binary of the numbers. Yes, here maximum जो भी आपके पास maximum number है. For example, AM has taken one example कि we have the sequence like 1 3 7. तो यहाँ पे maximum number के that is 7. I can represent 1 as 0 1. 3 can be represented as 1 1. 2 bits are sufficient to represent these. But if I want to represent 7, I need at least 3 bits. So this means that these numbers will also be represented using 3 bits. 3 bits means 3 flip-flops are required. Clear? It is not dependent on the number of ones. It depends on the number of bits. What if it is 1 0 1? Then will you be taking 2 flip-flops? Obviously not. So it is not dependent on the maximum number of ones. In this case, the number of ones are 2, but how many flip-flops are required? 3 flip-flops are required. First step clear हुआ? Yes? No? May or may not be crystal clear? Yes, it simply depends on the number of bits. Binary number of ones नहीं होते बच्चे, उसको bits बोलते हैं. पूरा डिजिटल खत्म होने वाला है. 1 is the bit value. So in simple terms, you can say that it depends on the number of bits. This is the first step. I hope first step is clear to everyone. Now, whatever input is given to you, according to that, draw the state diagram, which will be showing all the possible states. Right? State diagram banane ka purpose kya hai? It will tell you that what will be the next state. For example, if this is the sequence, so 1 is represented as 0 1. What is the next state? After 1, it is going to the 3. That can be represented as binary of 3 is 1 1. 3 से next state कौन सी है? It is going to 2. 2 can be represented in binary as 1 0. Next state is 0. 0 in binary is represented with 2 bits as 00. So this is the state diagram. So depending on the basis of the given input, we can draw the state diagram. That is the second step. So draw the state diagram showing all the possible states, whatever is given in the question. Next one. After that, we have to select the type of flip-flops to be used and write the excitation table. Now this will be given in the question that you have to design a synchronous counter for the given input using T flip-flop, using D flip-flop, using JK flip-flop, using SR flip-flop. Right? So using that, we have the present state, we have the next state. अगर आपको present state मालूम है, you know the next state, next output is also known, then on the basis of that, what you can return? Using excitation table, you can get the inputs for the flip-flop. If आपको counter construct करना है using T flip-flop, तो आप क्या use करोगे? You will be using the excitation table of T flip-flop. अगर counter construct करना है using D flip-flop, on the basis of these values, you will be using the excitation table of D. If it is using SR, use excitation table of SR. If it is JK, use the excitation table of JK flip-flop. So we have to construct a table which will be representing the present state. For example, if the present state is 0, 1, this is the present state. What will be the next state? That is 1, 1. So if it's the least significant bit, so correspondingly least significant bit is this. So let me call this as Q1, Q0. This is Q1, Q0, next bit. So this way we can construct the table. On the basis of this, we can apply the excitation table. और जब आपके पास एक्साइटेशन टेबल आ जाएगा, यू कैन राइट द इक्वेशन फॉर टी और डी. So accordingly you can write, you can get the minimal expression, draw the logic diagram based on the minimal expression. So these are the steps needs to be followed for the design of counter. कैसे याद रख सकते हो? It is nothing but SNEC BD. What is SNEC BD stands for? SNEC stands for state diagram. Okay, let me write this on the next slide. यहाँ तक clear है? So what steps we have to follow? Question कैसे given होगा? They'll say that design a synchronous counter for the count sequence of 0, 3, 1, 2. फिर से वापस 0 आ रहा है, यानी कि आपके पास एक साइकिल फॉर्म हो रहा है using D flip flop. Okay, so what steps needs to be followed? अब ऑब्वियसली बात है कि आप बोलोगे मैम गेट में डिजाइनिंग तो नहीं आएगी, तो आपसे ये पूछा जा सकता है कि जो इनपुट आ रही है दैट इज यूजिंग विच गेट, और इनपुट इज कनेक्टेड टू व्हाट इनपुट्स एंड व्हाट आउटपुट्स. कनेक्शंस पूछे जा सकते हैं, दैट कैन बी आस्क्ड इन द गेट पेपर. सो व्हाट स्टेप्स वी हैव टू फॉलो? वी हैव टू फॉलो basically 6 steps. First of all, we have to construct the state diagram. State diagram. Then we have to construct the next state table. State table. We have to use the excitation table of the required flip-flop. Excitation table. Excitation table पे जो भी आपको outputs आ रही हैं, for that you can write the expression using K-map. K-map will be used to get the Boolean equation. To get the Boolean equation, and on the basis of the minimized Boolean expression, Boolean equation, क्योंकि K-map will be giving you the minimized expression, on the basis of that you can design the counter. Now let's execute all these steps with the help of an example. This is the question. So in this case, first of all, we need to draw the state diagram. State diagram is how many bits will be used? Obviously, we will be using 2 bits. So 0, 0. Next state is 3. Next state is 1. Binary of 1 is 0, 1. Next state is 2. Binary of 2 is 1, 0. 2 के बाद वापस कहाँ पे जा रहा है? Again it is going to 0. So this is the first step, that is state diagram. Clear? This is the first step. Next step is to come up with a state table. So here let's consider the previous state or the current state, and here we have to write the next state. Let us consider this as the current state. Next state, current state में how many bits? Every state is represented with 2 bits. So let me take this as Q1 and Q0. Next state को हम represent करवा देते हैं Q1 and Q0, क्योंकि next state में भी आपके पास 2 bits आएंगी. So next को represent करने के लिए हम plus कर देते हैं. Now on the basis of this we have to write the outputs. Output किसके लिए लिखोगे? Q1 and the next output, that is, let's assume D1 and D0. For this we have to use the excitation table of the required flip-flop, that is the D flip-flop. Excitation table. Now what is the current state? That is 0. 0 के लिए what is the next state? That is 1, 1. Next state is 1, 1. Write down all the states. These are the possible states. Now for 1, 1, what is the next state? It is 0, 1. For 0, 1, next state is 1, 0. For 1, 0, next state is 0, 0. So this is how we have we have constructed the next state table. यहां तक कोई डाउट? Yes, no? If I talk about the excitation table of D flip-flop, I just hope that कि आप सबको excitation table construct करने आते हैं. So if the output is Q and this is the next output Q plus, output क्या आएगी? With 2 inputs, 4 combinations are possible. 1, 1. So here delayed, what output is expected, that is 0. तो input क्या होगी? Obviously अगर input 0 है तो ही output 0 मिलेगी. If input is 1, then you will be getting the output as 1. So this is the excitation table of D flip-flop. So whatever is the expected output, that will be the input. So here, if the expected output is for 1, I'm talking about the most significant bit. It is 1, 0, 1, 0. So I'm getting these values on the basis of the excitation table. I'm referring to this excitation table. So we have used the excitation table. After that, we have to get the equations. आप equations, Boolean algebra के rules use करके भी you can get the minimal expression, or using the K-map also you can get the minimal expression. So you can use the K-map or you can use Boolean algebra rules. So if I'm using this, one value कहाँ पे आ रही है? This is the current input, right? This was the input and on the basis of that we have determined the next output. So कौन से input के corresponding you are getting the value 1? For D1, we are getting the value 1 here. That is Q1 complement, Q0 complement. 1 you are getting here, that is Q1 complement and Q0. So if you will be taking Q1 complement, this comes out to be Q1 complement. This is the minimized expression. Similarly, write the Boolean equation for D0. Getting 1 here. So that is Q1 complement, Q0 complement and Q1, Q0. That is nothing but Q1 XOR Q0. Clear? So we got the Boolean equations. Next step is you can use the concept of K-map or directly you can write the equation. It's totally your choice. The ultimate thing is you have to get the minimal equation. What is the last step and the final step? That is the designing of the counter. How to design this counter? How many counters, how many flip-flops we have to take? We have to use 2 flip-flops. So take 2 flip-flops. Take 2 flip-flops. Connections क्या होंगे? We have to determine that. What is the most significant bit? That is the Q1. So don't mix it. अगर आपने most significant position पे Q1 लिए, then take it as Q1. Q0 complement. What flip-flop we have used here? Using the D flip-flop. So it is D. D1 and D0. What is the input for D1? This is synchronous counter. So common clock is applied. Common clock is applied. This is clock. Please explain D0. Excitation table में problem है या फिर equation में problem है? D1, I'm writing the equation using SOP form. तो SOP में हम किस पे focus करते हैं? We are focusing on 1. 1 कहाँ पे आ रहा है D1 के लिए? At these 2 positions. So corresponding to this one, what was the input? It was 0, 0. In SOP form, if it is 0, then this means that it is representing the complemented variable. If it is 1, then it will be representing uncomplemented variable. So for D1, we are getting 1 at 2 places, 1 here. So this comes out to be, this term comes out to be Q1 complement, Q0 complement. Second one कहाँ पे आ रहा है? Second one, yes, it will be X0. X0. Second one कहाँ पे आ रहा है? Second one we are getting at Q1 complement Q0. Q1 complement Q0, and after the simplification we are getting this as Q1 complement, right? In the next, we are getting 1 here and 1 here. Corresponding to this one, input was 0, 0. So this comes out to be Q1 complement, Q0 complement, and plus Q1, Q0. That is nothing but XNOR gate. So now use this in the diagram. D1 is getting the input from where? Q1 complement. So Q1 complement is here. Q1 complement is behaving as the input for D1. Yes? Ma'am, Q0 and Q0 complement we should consider where? This is considered, on the basis of this, we have used the excitation table to get the output of D1. यहाँ पे आपने excitation table use किया, and on the basis of that we have determined D1. Use the excitation table on Q0 and Q0 plus 1. So on the basis of that we got D0. In D1 में we have to consider the given input. बच्चे ये input है. On the basis of these input, this is the input. So I have taken the sequence that is 0, 3, 1, 2, which is written in the binary form. On the basis of this input, we have determined the next state. So this is not given in the question. तो जब भी आप equation लिखते हो तो किस terms में लिखते हो? Whatever is given as the input. So D1 is given as Q1 complement, so it's connected with the Q1 complement. Clear? Similarly, D0 के लिए input क्या होगी? That is nothing but Q1 XNOR Q0. So Q1 XNOR, use the XNOR gate, and inputs for XNOR are Q0 and Q1. This is behaving as the input here. So in exam, they may ask for these equations. Obviously, they won't be asking for this thing. They won't be asking for this thing. They will be asking for the equations. So basically, till this point, it's very important. Clear? Any doubt? Query? This is the first example. On the basis of this, I'll be taking 2 more examples. Let's move on to our next example. Again, I want to draw a synchronous counter for the same sequence using T flip-flop. Here we have used D flip-flop. Now I want you to use T flip-flop and return the equations. Design a synchronous counter for the count sequence 0, 3, 1, 2, 0 using T flip-flop. First of all, you have to come up with the state diagram. State diagram 0, 0, 1, 1. We have 0, 1, 1 and then 2. State diagram. On the basis of this, now you have to come up with the next state. Input is given as, what are the inputs? Current states, which is given as the input. That is 2 inputs, 2 bits are there. So let's take this as Q1 and Q0. That is 0, 0, 1, 1, 0, 1 and 1, 0. On the basis of these inputs, we will be determining the next state. Whatever I have written with the blue, that is the input, is information ko use karke we have to determine the next states. Q1 plus and Q0 plus. 0 0 के लिए next state is 1 1. 1 1 के लिए next state is 0 1. 1 0 and it is 0 0. So this we have determined. Now on the basis of this, we have to use the excitation table of T. So Q1 or Q1 plus को consider करोगे because excitation table, in excitation table we need the previous output and the next output. Excitation table में as an input we are having the current output, previous output and the next output. And on the basis of that we have to determine the values. So अगर Q1 ले रहे हो तो आप excitation table Q1 और Q0 पे apply नहीं कर सकते हो because these are the outputs for the previous for the current state and these are the outputs for the next state. So its combination will be taken with Q1 and Q1 plus. Confusion दूर हुई? Now with this 4 combinations are possible. 1 0 and 1 1. What is the excitation table of T flip-flop? T flip-flop में value कब toggle होती है? When the value are toggled when the value of T is 1. यहाँ पे value toggle नहीं हुई है. This means that T was 0. Input for T was 0. अगर T की value 1 होती तो previous output और next output में values toggle होती. Here the values are toggled. This means that the input must be 1. Values are toggled. Input must be 1. Values are same. So it must be 0. So this is the excitation table of T flip-flop. Now use this here to determine T1 and T0. Use the excitation table on this one. 0 and 1, there is a change. 1 and 0, there is a change. Values are toggled. Values are toggled. Values are toggled. Similarly for T0, 0 1, values are toggled. 1 1, values are not toggled. Values are toggled. Values are not toggled. Now can you determine the equation for T1? Determine the equation for T1 and T0 and on the basis of that we can design the counter. T1 अगर बच्चे आप K-map construct करते हो 2 variable K-map, so in that case if all the bits are 1, so ultimately T1 will be returning what? It is returning 1. Boolean algebra rules apply करोगे, minimum expression will be 1. What about T0? Let me write here so that we get a space for designing of the counter. T1 will be 1 and T0 will be, you are getting 1 here and 1 here. Consider the inputs for the first row and the third row. It will be Q1 complement, Q0 complement plus Q1 complement and Q0. This comes out to be Q1 complement. So we got the equations, design the counter. Two flip-flops are used. Let's assume that this is T1, this is T0. Here the output is Q1, Q1 complement, Q0, Q0 complement. Same clock is applied. बच्चे मैं K-map की details में नहीं जा रही हूँ because K-map we have discussed in detail. Minimization आपको minimized equation return करनी आती है. So I'm not going into the much details of the minimization. So what is T1? Input for T1 is always 1 and for T0 it is Q1 complement. It is Q1 complement. Clear? So this is a synchronous counter for the count sequence 0, 3, 1, 2 using T flip-flop. So similarly, you can use the concept of JK flip-flop as well as SR flip-flop. बच्चे T0 के लिए मैंने कुछ नहीं किया, सिर्फ मिनिमाइजेशन की है. 1 you have got here, इसके करस्पॉन्डिंग एक्सप्रेशन कहां से मिलेगा? फ्रॉम हियर. श्वेता मुझे ये बताओ बच्चे, आपने मिनिमाइजेशन पे सेशंस अटेंड किए हैं? इफ आउटपुट इज देयर, डू यू नो दैट हाउ टू राइट द एक्सप्रेशन? अगर उस टॉपिक में कोई डाउट नहीं है तो अननेसेसरली आप इसमें कंफ्यूज हो रहे हो. जहां पे भी आपके पास 1 आ रही है, दिस इज द आउटपुट. जो आउटपुट 1 है उसके करस्पॉन्डिंग व्हाट इज द इनपुट? दैट इज 0 0. आई एम यूजिंग SOP फॉर्म, दैट्स व्हाई इट इज फोकसिंग ऑन 1. So it is Q1, value is 0, so it means that it is Q1 complement and Q0 complement. Next time 1 kahan pe aa raha hai? It is coming here. What are the bits? It's Q1 complement and Q0. और simplification की है by applying the Boolean algebra rules. Ma'am, counter से किस type के questions आते हैं? They'll give you like if this is given as the input, they'll give you this as the counter and they'll say that determine that what will be the output. What will be the output sequence? This is one type of question. Other type of question can be based on the number of states that can be generated. Okay. Ring counters में से questions आ सकते हैं आपके पास on the basis of number of unused states or on the basis of number of used states. Okay, or they may give you some counter. कोई डायग्राम गिवन होगा और आपसे पूछा जाएगा कि नेक्स्ट 3 क्लॉक पल्सेस में व्हाट विल बी द आउटपुट और व्हाट विल बी द आउटपुट सीक्वेंस, समथिंग लाइक दैट. सो बेसिकली दीज आर रिलेटेड टू द आउटपुट्स. You should know that how synchronous and asynchronous counters are working. Don't worry, I'll be discussing all the types of questions in the special class. Clear? Let's take one more example and then we'll be moving on to the next type of counters, that is asynchronous counters. Here you have to design a synchronous counter for the count sequence. Count sequence is given as 5, 7, 1, 2, 6, 3, 4, 0 using JK flip-flop. So first of all, determine the number of flip-flops required or number of bits required to represent each number, each count. How many flip-flops will be there in the counter? बच्चे कितने flip-flops use होंगे to get the sequence? In this count sequence, what is the maximum? When we'll be having special class on these topics, we will be having a special class on this topic on Tuesday. I'll be discussing the schedule in the end of the session, so just hold on. How many flip-flops are required? If you have not watched any special class, you can use the referral code. You have to use the referral code to unlock the special class. So don't forget to apply the referral code Shefali to follow my special classes, and my Unacademy profile link is given in the description box. In detail, I'll be discussing the schedule at the end of this video. Okay, so in this case, maximum number is 7. How many bits are required to represent 7 in the binary? It's 3 bits. So this means that 3 flip-flops will be required. First step is to come up with the state diagram. Draw the state diagram. So 5. Next we have 7, 111, Next we have 1, 0, 0, 1. Next we have 2, 0, 1, 0. Next we have 6, 0, 4, 6. Next we have 3, 0, 1, 1. Next we have 4, it's 1, 0, 0. Correct? And then we have 0. बच्चे इसको सर्कल में बना लेना, but yeah, at least you can understand that what is the next state. Three flip-flops are required. So the starting state is 5. So construct here the diagram states how many bits are required. 3 bits are required. Let me take this as Q2, Q1 and Q0. On the basis of this, we can determine the next state. Next state may be obviously 3 bits will be there, Q2, Q1 and Q0. And on the basis of this, let's write the states. First one is 5, 7, 1, 2, 6, 3, 4 and 0. Now determine the next states. I'll not be completing this, okay? So in the next session, I'll be asking for the equations that you are getting for after the minimization, but definitely will do till the excitation table, and I'll be returning one equation for any of the output. So here we will be getting a 5 ke next state ke, that is 7. 7 se next state ke, that is 0, 0, 1, 1. Next one is 2, 0, 1, 0. आप यहाँ से भी direct copy कर सकते हो, or you can copy it from here. 2 की next state is 6. 6 से next state is 3. 3 से next state is 6 to next state is 3. 3 to next state is 4. 4 to next state is 0. 0 to next state is 5. Now on the basis of this, we have to use the excitation table on bit number 2, on bit number 1, on bit number 0. So we will be getting here J2, K2, J1, K1, J0, K0. Right? What is the excitation table of JK flip-flop? Excitation table of JK flip-flop will be used. Q, Q plus, outputs J and K. 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. What is the excitation table? It's 0 cross, it's 1 cross, cross 0. Yes? यही excitation table? सबको construct करना आता है. Now use the excitation table Q2 and consider the bits Q2 and Q2 plus 1, 1, it's cross 0. 1 and 0, it's cross 1, don't care 1. 0, 0 के लिए it's 0, don't care. For 0, 1, it's 1, don't care. For 1, 0, it's don't care 1. For 0, 1, it's 1, don't care. For 1 and 0, it's don't care 1. For 0 and 1, again it's 1, don't care. Got it? Are you all getting this as the output? Similarly, return the values of J1 and K1. I'm writing the values here. आप भी values लिखो. And then you can tally. 1, don't care. Then it's 1 and 0. For 1 and 0, it's don't care 1. Don't care 1. And then we have 1, don't care 0, don't care 0, don't care 1, 0, don't care, and 0, don't care. Similarly, write for J0, K0. Done. Now you can determine the equations जहाँ पे values आपके पास 1 आ रही हैं, वहाँ से ले सकते हो. So many don't cares are there. So in this case, I'll suggest you to come up with a K map. With a K map, easily you can get the outputs. But K map draw करते हुए बच्चे आपको थोड़ा सा यहाँ पे ध्यान रखना है. ध्यान क्या रखना है? यहाँ पे आपके पास values जो आ रही हैं वो sequence में नहीं है. Okay, this is not 0, 1, 2, 3, 4, 5, 6, 7, 8. जो आपके पास सेल होते हैं K map के, those are arranged. Okay, so I can't change the position of the image. Let me rewrite it. कहाँ तक कौन सी लास्ट कितनी रोज में प्रॉब्लम आ रही है? I hope till this point it's clear, right? So whatever portion I have written here, I'm writing on the top of the slide. So for J1, K1, J0 and K0, I'm writing it for the last 3 rows. It is cross don't care 1, 0 don't care, 0 don't care, 0 don't care, 1 don't care. Now is this fine? So this portion I have written here. यहां तक कोई प्रॉब्लम? मैं सिर्फ एक इक्वेशन के लिए के मैप कंस्ट्रक्ट करके आपको दिखा रही हूं हाउ टू जनरेट द इक्वेशन फॉर द रिमेनिंग equations. You have to return the equation for J2, K2, J1, K1, J0, K0. So basically you will be getting the equations using 6 K maps. K map for J2, K map for K2, K map for J1, K map for K1, K map for J0, K map for K0. यहाँ तक clear है? So let's find out the equation for J0. Okay. So I'm constructing the K map for J0. So the most significant bit is this is the inputs, right? We have to consider these inputs. So we have Q2 complement and Q2. We have Q1 complement, Q1 complement, Q0 complement. Here we have Q1 complement, Q0, Q1, Q0, Q1 and Q0 complement. अब बच्चे आप ब्लाइंडली यहाँ पे फिल नहीं कर सकते पोजीशंस. दिस डोंट केयर कौन सी पोजीशन के करस्पॉन्डिंग है. और इफ आई राइट द पोजीशंस हियर, if I write the positions, this is position representing to 0, 1, 3, 2, 4, 5, 6 and 7. Correct? Now this is nothing but 5, this is 7, this is 1, this is 2, or let me write here, चलो यहीं पे ठीक है, 6, 3, 4 and 0. This is 4 and 0. So 5 के corresponding what bit you are getting? Corresponding to 5 we are getting don't care. Corresponding to 7 we are getting don't care. Corresponding to 1 we are getting don't care. Corresponding to 2 we are getting 0. 0 को हम include नहीं करते हैं. So I'm not including this. If you want to include, you can. Next, corresponding to 6 we are getting 1. Corresponding to 3 we are getting don't care. Corresponding to 3 we have don't care. Corresponding to 4 we have 0. Corresponding to 0 we have 1. So these are the entries in the K-map. I have not marked one don't care. Don't care is corresponding to 5, 7 and 1. 5, 7 and 1 and corresponding to 3. Okay, all are marked. Now can you form a quad? You have to minimize the equation. Can you form a quad? Quad is not possible here. So in order, we have to cover all the ones. So this can be covered using the pair. So what equation you are getting for J naught? Corresponding to J naught, we are getting the equation. This is Q2 complement and Q1 complement. Q2 complement and Q1 complement. Corresponding to this pair, it is Q2 and Q1 plus Q2 and Q1. So this is nothing but this is Q2 XNOR Q2 XNOR Q1. So this is the equation for J naught. Equation से implement कैसे करने वो बिल्कुल clear है सबको. So similarly assignment आपके लिए क्या है? I have constructed the complete table. You have to find out the equations for J2, K2, J1, K1. J naught के लिए I have already done for K naught. In the exam, obviously they won't ask you for the designing of the counter. They may ask for the equation. तो सारी equations आपसे 6 की 6 equations नहीं पूछेंगे. जो भी equation पूछी है उसको आप return करवा दो. इस question में सिर्फ एक ही twist था during the minimization. Normally आप कैसे values fill करते हो? In the sequence. But here the positions are not in the serial order. So you have to consider the positions while marking it in the K-map. Any doubt in the designing of synchronous counter? So we have taken 3 examples using T flip-flop, using D flip-flop, using JK flip-flop. Same concept can be used using the SR flip-flop. जो भी flip-flop दिए बच्चे, just you have to consider the excitation table of that particular flip-flop. If you have any doubt, you can ask. Otherwise, we'll move on to the next category of counters, that is asynchronous counters. Clear? Very good. Clear to everyone? So next we have asynchronous counters. Asynchronous counters are also known as ripple counters. So asynchronous counters में synchronous और asynchronous में difference के same clock is not, common clock is not controlling all the flip-flops. So external clock is only applied to one flip-flop and that flip-flop will be returning the least significant bit. जिस भी flip-flop को सिर्फ एक ही flip-flop को outer clock applied होगी and that flip-flop will be behaving as that will be giving you the output for the least significant position. So asynchronous counters do not have a common clock that controls all the flip-flop stages. The control clock is input to the first stage, सिर्फ first stage पे आपके पास control clock as input आएगी, and the clock for बाकी की जितनी भी stages होंगी for the subsequent stages it is obtained from the flip flop of the prior stages. Means पहली वाली stages की जो भी output होगी that will be behaving as the input for the subsequent stages of the asynchronous counter. Clear? Let us consider one example. For example, if this is some asynchronous counter, this is, let's say, flip flop 0, this is flip flop 1, this is flip flop 2, this is, so this is, let's assume कोई भी आप flip flop ले लो, let's take JK flip flop, JK, J1, K1, J2, K2. These are the inputs. Some inputs are taken. Let's assume that these inputs are 1. अभी के लिए हम inputs को consider नहीं करें. We are not focusing on the working. I just want you to explain that which will return you the least significant bit. Normally exam में क्या होता है? They'll give you a diagram something like this. और आउटपुट्स जो पूछे होते हैं वो रिवर्स ऑर्डर में आती है. कंफ्यूजन इज व्हाई दैट इज रिवर्स्ड. सो लेट्स अज्यूम दैट हियर वी हैव टू कंसिडर दिस एज वेदर द क्लॉक इज पॉजिटिव और नेगेटिव. In asynchronous counter it matters, but in case of synchronous counters it doesn't matter whether it's the positive edge triggering or negative edge triggering. So negative is represented with a triangle with a bubble. Let's assume that external clock is applied to flip-flop 0. And here we will be having the outputs. Every flip-flop is having two outputs which are complement of each other. Here also we will be having two outputs which will be complement of each other. Okay. So one flip-flop is getting the external clock and other stages will be getting the clock from the subsequent stages. यहाँ पे जो भी output है that will be controlling the next flip-flop. For example, this is connected with this one. This is connected with this one. So in this case, if you are getting the output as Q0, Q1 and Q2, Q0, Q1 and Q2, or you will be writing this as Q2, Q1, Q0. Okay. So in this case, what will be the most significant and what will be the least significant? This is one of the very important point जिसमें normally mistakes होती हैं exam में. So this flip-flop 0 is getting the external clock and it is producing the output. What is its output? That is Q0. So this is representing the least significant bit. And obviously this will be the most significant bit. If the output is returned in this manner, so this is Q0 is representing the least significant bit. This is the most significant bit. आउटपुट किसी भी ऑर्डर में पूछी हो सकती है. कंफ्यूजन के लिए, कंफ्यूजन क्रिएट करने के लिए ऑर्डर चेंज कर देते हैं. सो जस्ट कीप इन माइंड कि जो भी फ्लिप फ्लॉप को एक्सटर्नल क्लॉक मिल रही है दैट विल बी प्रोड्यूसिंग द आउटपुट विच विल बी बिहेविंग एज द लीस्ट सिग्निफिकेंट बिट, एंड जो भी लास्ट स्टेज पे फ्लिप फ्लॉप होगा दैट विल बी रिटर्निंग द मोस्ट सिग्निफिकेंट बिट. सो इन दिस केस most significant bit is 1 and most significant bit is represented with Q2 and this is least significant bit. इस पॉइंट में कोई डाउट? तो आउटपुट सीक्वेंस ऑर्डर कोई भी हो सकता है. जस्ट कंसिडर, or they can ask for the least significant bit is 0 or 1, most significant bit is 0 or 1, something like this. So asynchronous counters are also known as ripple counter. Basically in asynchronous counters we have the up counter and the down counter. By just looking at the diagram we can identify that the counter will be the up counter or the down counter. So first of all let's talk about 3-bit ripple up counter. 3-bit ripple up counter. First of all, I'm taking the counter and on the basis of that, we will be determining that what 4 combinations are possible. जो आपके पास एज ट्रिगरिंग है, दैट कैन बी पॉजिटिव एज ट्रिगरिंग और नेगेटिव एज ट्रिगरिंग. Here I have considered the negative edge triggering. यहाँ पे आपके पास positive edge भी हो सकती है, and here it is connected with the Q naught. It can be connected with the complemented output. It can be connected with the complemented output or uncomplemented output. So on the basis of that, we will be having 4 combinations. First of all, let's talk about the ripple counter. And why the given counter is known as the up counter, we will discuss that after generating the outputs. Let's assume that I'm taking the same flip-flop that we have considered in the previous example. 2 outputs are there which are complement of each other. Input is fixed, that is 1, and it's working on negative edge triggering. Next flip-flop we have, in which the input is J1 and K1, output is Q1 and Q1 complement, negative edge, and this is controlled by Q naught. Here we have next flip-flop. Inputs are J2 and K2. Outputs are Q2 and Q2 complement. This is negative edge triggered. And here the inputs are fixed for all. When the value of J and K is 1, in that case it is behaving as a toggled flip-flop. अगर दोनों values 1 है तो हमेशा क्या करेगा? It will toggle the value. अब asynchronous में वर्क कब करेगा? दिस इज नेगेटिव एज ट्रिगरिंग. लेट्स डिटरमाइन द आउटपुट फर्स्ट. सो इन दिस केस इनिशियली व्हेन नो क्लॉक इज अप्लाइड, okay, let's take here, when no clock is applied, outputs can be written as this is the least significant bit and this is the most significant bit. क्यों इसको least significant बोले? Because external clock is applied to this flip flop. So I'm writing this as Q2, Q1 and Q0. Now, when no clock is applied, initially let's assume that the outputs are 0. Now, when first time clock is applied, जो भी आपके पास बचे first flip flop है, that will always toggle the value. Because toggle क्यों कर रहा है? Because the value of J and K is 1. So if J and K is 1, so every time it will be taking the complement of the previous output. So when the first clock is applied, it will be complementing the value. So Q naught की value क्या होगी? Q naught की value क्या होगी? Previous value is 0, now this will become 1. First of all, let's understand that what is positive edge triggering and what is negative edge triggering. If it is going to change the value, एज का मतलब के दिस थिंग, एंड इफ इट इज लेवल ट्रिगरिंग, लेवल क्या होगा? दिस इज लेवल 0 एंड दिस इज लेवल 1. बट हियर वी आर टॉकिंग अबाउट द पॉजिटिव एंड द नेगेटिव एज ट्रिगरिंग. सो वैल्यू कब चेंज हो रही है? व्हेन पॉजिटिव का मतलब क्या है? व्हेन इट इज गोइंग फ्रॉम 0 to 1, राइट? नेगेटिव इज व्हेन 0 to 1, when it is changing the level. This is positive edge triggering. Positive edge triggering. Negative कब होगा? When it is coming from 1 to 0. This is 0 and this is 1. When it is coming from 1 to 0, then that is known as negative edge triggering. अब क्वेश्चन ये आता है कि मैम याद कैसे रखें कि किस में 0 to 1 हो रहा है और किस में 1 to 0 हो रहा है? No, it is everything initially. See, these inputs are fixed. J0, K0, J1, K1, J2, K2, all these inputs are fixed to 1. This is the given given counter. आप यहाँ पे toggle भी कर सकते हो. If you are using T flip flop here, you can take this as 1. Okay? अब confusion ना हो कि 0 to 1 पॉजिटिव में होता है या फिर नेगेटिव में. Consider one example. फॉर एग्जाम्पल, पहले आपकी कोई भी पोजीशन नहीं आती थी. 0 पोजीशन यू हैव ऑब्टेन्ड in your exams, but suddenly you got first position, तो आपको पॉजिटिव फीडबैक मिलती है या फिर नेगेटिव मिलती है? जीरो से अगर आप 1 पे जा रहे हो, 0th पोजीशन से फर्स्ट पोजीशन पे आ रहे हो, then it's a positive achievement, right? So that is 0 to 1. 1 to 0, फर्स्ट पोजीशन से अब आपकी कोई पोजीशन नहीं आई, तो ऑब्वियसली बात है डांटी पड़ेगी कि बेटा आप केयरलेस हो गए हो, आपने पढ़ाई छोड़ दी है, दिस एंड दैट, right? So that means if it is coming from 1 to 0, then this is considered when it's negative edge triggering. Negative edge triggering, negative clock को हम represent करते हैं with a bubble. In this particular case, it's working on, ये कब toggle करेगा? This flip flop, ये हमेशा active होगा. This will always toggle the value. जैसे ही clock apply होगी, it will always toggle. But ये कब toggle होगा? When the value of Q naught is changing from, this is negative edge triggering, when the value is changing from 1 to 0. Only then this flip-flop will be active. If the value is changing from 1 to 0, only then this flip-flop will be active. ये वाला flip-flop कब active होगा? This is negative edge triggering. So when the value of Q1 is going from 1 to 0, then this flip-flop will active. Input तो दी है, input is available, that is fixed 1. But जब तक clock pulse apply नहीं होगी, clock active नहीं करेगा flip-flop को, it cannot generate the output. ये point सबको समझ में आ गया? Now let's try to determine the outputs. So this clock is always applied. This is always providing the clock. So Q naught is complemented. What is the previous output? That is 0. So now the value is toggled to 1. So here we got the value 1. तो यहाँ पे change क्या है? It is changing from 0 to 1. 0 to 1 कब consider होगा? In the positive edge triggering, but this is negative edge triggering. So this means that this will not be active. ये active नहीं होगा. अगर ये active नहीं होगा तो यहाँ पे output क्या आएगी? See, there is a change. पहले वाले केस में synchronous में हम क्या कर रहे थे? We were setting the input और सबको एक साथ clock मिलती थी and we were writing down the output for all. Right? So in that case, just the previous output was considered because that was behaving as the input for the next clock. But here, current clock is also participating in deciding that whether the next stage flip-flop will be active or inactive. ये पॉइंट समझ में आया? सो हियर Q नॉट का जो चेंज हो रहा है, Q नॉट इज चेंजिंग फ्रॉम 0 to 1. तो इसका मतलब क्या है? इट वॉन्ट चेंज इट्स वैल्यू. इट वॉन्ट चेंज इट्स वैल्यू. Q1 will be producing the same output. जो भी आउटपुट यहाँ पे अवेलेबल थी, it remains the same because this is inactive. ये कब एक्टिव होगा? फ्लिप फ्लॉप 2 कब एक्टिव होगा? जब Q1 की वैल्यू 1 से 0 चेंज होगी, बट Q1 की वैल्यू 0 to 0 है, so this will remain inactive. So the output is 0, 0, 1. Clear? For the next clock, what will be the output? This will always be active, so this will toggle. Now here the value is changing from 1 to 0. अगर 1 to 0 आ रहा है, इसका मतलब क्या है? Flip-flop 1 will be active. 1 to 0 means now it got active. If it is active, input is set as 1. दोनों की value 1 है, so it will toggle the value. Toggle means whatever is the previous output, now it will take the complement of the previous output. What will be the complement of the previous output here? Previous output is 0. Now it comes to be 1. Q2 की output change होगी. Here the change is 0 to 1. So flip-flop 2 will be inactive. So it remains the same. 0, 1, 0. Next cycle में what will be the output? What will be the output? Q naught will change. This is a positive change, 0 to 1. So it will not change. It's because it's 0 to 1. So this remains inactive. Inactive means it will be returning the previous output. Now here the change is 1 to 1. So this will be inactive. For the fourth clock, this will be returning. It will change. change is negative 1 to 0 it is going. So 1 to 0 negative change we have to consider. So it will toggle, it will activate the flip-flop 1. So the output will toggle. Now here it is negative edge triggering. So the output will be 1 0 0. For the fifth one, it will change 0 to 1 positive. So but we have to consider the negative edge. So it won't change. No change here. For the sixth one, it will toggle negative. So it will change the value here. This is 0 to 1. It will not change. For seventh clock, it will change 0 to 1. This won't be activated. 1 to 1. This won't be activated. For eighth clock, this will change. 1 to 0 means it will also change. 1 to 0 means this will also activate. So it terminates here. So there are 8 states with definitely with 3 flip-flops. 8 combinations are possible, 2 raised to power 3. And why is this known as up counter? Because if you look at the values, this is equivalent to the binary of 0, 1, 2, 3, 4, 5, 6 and 7. So that's why this is known as up counter. Eight clock pulses. To represent 8 combinations, 8 clock pulses are taking place. If बचे या तो 0 0 वाला कॉम्बिनेशन ये कंसिडर कर रहे हैं हम, या फिर वी आर कंसिडरिंग दिस कॉम्बिनेशन. Clear? If we look at the timing diagram, so clock, first of all, let's consider the clock. This is clock 0. This is clock 1. Clock 2. Clock 3. Clock 4. Clock 5. Clock 6. We have clock 7, clock 8 and so on. This is one clock. Okay. So let us erase this. For a Q naught, if this is clock 0, this is clock 1, this is clock 2, this is 3, this is 4, 5, 6, 7, 8 and so on. So here this is the negative triggering. This is the negative triggering. This is the negative triggering, negative triggering, negative triggering, negative, negative, negative and so on. So if here, when it's going from 0 to 1, after applying the first clock, जैसे आपके पास first clock आती है, पहले आपके पास what is the value of Q naught? That is 0. It is 0. Then it is changing its value. In the next clock, it is 1. For clock 1, it is 1. For clock 2, it is 0. For clock 3, it is 1. For clock 4, it is 0. For clock 5, it is 1. For clock 6, it is 0. For clock 7, it is 1. For clock 8, again it will become 0. Now this is for Q naught. Depending on the value of Q naught, we are considering the negative edge triggering. Negative means it is going down here. At this position, on the basis of this, Q1 will be changing the output. So for 0, so initially this is 0. कब तक 0 रहेगा? It remains 0 जब तक negative edge triggering नहीं होती. जैसे negative edge trigger होगा, it will change its value. For clock 1 and clock 0 and clock 1, the value was 0, so it is 0. Now it's the negative edge triggering, so this is going to change its value. It's toggling its value. दोबारा से toggle कब होगा? When negative edge triggering will come up. Right? Q1 is active or inactive based on the value, based on the output of Q0. Again, it has toggled the value, it remains 0. दोबारा toggle कब होगा? When negative edge triggering occurs, remains 1. Again, it will change the value here and so on. Similarly, Q2 के लिए what will be the timing diagram? Q2 is 0 till what point? जब तक Q1 में value 1 से 0 नहीं होती. जब तक 1 से 0 value नहीं होती, तब तक Q2 will not change its level. So it is on level 0. This is 0, 0, and here negative edge triggering took place. So in the fourth cycle, fourth में first time it got the value 1, got the value 1, and so on. This is the timing diagram. So for how many clock pulses? यहाँ पे this is representing this as, if this is t, this is representing as 2t. This is representing 4t. This is 8t. Clear? So what is the propagation delay? If we have n bit triple counter, then what is the propagation delay of each flip-flop? It is nothing but that is TPD divided by the number of, divided by the frequency. Alright? So this is all about up counter. बाकी सबके लिए we will not be drawing the timing diagram. Just you should have a clear idea कि timing diagram कैसे construct होते हैं. That is sufficient. Now, in the previous case, we have talked about the negative edge triggering. Negative edge triggering. Triggering can be positive edge triggering or negative edge triggering. It can be positive edge triggering or it can be negative edge triggering. If negative edge triggering is there, तो जो आपके पास clock है, clock can be connected with it can be connected with uncomplemented output. It can be connected with complemented output. It can be connected with complemented output. It can be connected with uncomplemented output. If negative edge triggering is there and it is connected with the positive edge triggering, then it is connected with the positive output, then that is known as, that will give you, always it will give you the up counter. If it is negative edge triggering, this will give you the down counter. Like in previous case, we have considered the negative edge triggering and the clock was connected with the uncomplemented output. So in that case, we got the up counter. Positive edge triggering you have to use and it's connected with the Q, then it will be giving you the down counter. And this will be giving you the up counter. Clear? For this, let's consider one more example. Let's consider 3-bit triple counter. In the 3-bit triple counter, now I'll be using the positive clock पॉजिटिव एज ट्रिगरिंग, एक एग्जाम्पल हमने नेगेटिव पे किए, नेक्स्ट एग्जाम्पल आई एम टेकिंग ऑन द पॉजिटिव clock using here T flip-flop, and the value is set to 1. T is equal to 1 is nothing but this is same case as that of J is equal to 1 and K is equal to 1. T flip-flop, let me call this as T0, T1, T2. Output is Q0, Q0 complement, Q1, Q1 complement, Q2, Q2 complement. Now this is positive clock, and we want to construct the down counter. If it's the positive clock, then it will be connected with what? It will be connected with Q0. It will be connected with uncomplemented output. Input is set as 1, input is set as 1. Now can you determine the outputs? Just apply the cycles and see what output you are getting. If the working is clear, then easily you can determine the outputs. Initially clock is 0. Outputs are, this is getting the external clock. So this means that Q0 will be this will be the least significant bit and this will be the most significant bit. So let me write this as Q2, Q2, Q1 and Q0. Initially these are 0. First clock is applied. Obviously this will always toggle its value. So this will toggle. It has toggled the value from 0 to 1. 0 to 1 means positive. 0 to 1, then it will be active. If it is changing from 0 to 1, then flip-flop 2 will be active. This is flip-flop 1. This is flip-flop 0. Since the value is changing from 0 to 1, this means that flip-flop 1 is active. This will also toggle the value of Q1. So this comes out to be 1. 0 to 1 it has toggled. Next, 0 to 1 it has toggled. This means that flip-flop 2 is also active. This will also toggle the value previous output. So this will be 1. Now go to the next clock. First clear difference. First output is clear. Apply second clock. This will toggle its value 0. Value is changing from 1 to 0, but it's working on the positive edge triggering, so this won't change. This is not positive change, so this won't change. Ma'am, please repeat. Okay. For clock 1, सबसे पहले identify करो ये clock कौन सी है. This is positive clock. अगर आपको something like this is given, this means that positive. And if bubble is there, this means that negative. Positive edge triggering में active कब होगा? Positive edge triggering में flip-flop will be active when the change bit output is changing from 0 to 1. Negative edge triggering में change कब होगा? When the output is changed from 1 to 0, only then the flip-flop will be active. पहले वाले केस में I have taken the negative edge triggering. Now in this case we are taking the positive edge triggering, right? Q0 is the least significant bit. This will always toggle its value because it's getting the clock from the external source. So this has toggled its value. T is equal to 1. T की value 1 है. इसका मतलब कि T flip-flop कैसे work करते हैं? It will toggle the value. If T is equal to 0, it will not toggle. Remains the same. Toggle the previous output, doesn't toggle the previous output. Clear? तो यहाँ पे Q0 की value toggle होगी. Now if you look at the output change. Previous output was 0. Now the output is what? 1. So it's 0 to 1. 0 to 1 means if positive edge triggering is there, 0 to 1 means this flip-flop got active. If this is active, this was getting the input 1. See, जब भी आप कोई भी output को note करते हो, you need to have the input as well as the clock. Clock is obtained here. So 1, it is going to toggle the value. The previous output for Q1 was 0. Now this is toggled to 1. So that's why I have written here Q2 के लिए what was the previous value? That was the 0. Now since it's 0 to 1, that is a positive edge triggering. So this is working on positive edge triggering. So this flip-flop got active. अगर ये flip flop active हो गया तो t की value 1 है तो it will toggle the previous output. This will toggle it to 1. So the output changes from 0 to 1. Right? Now in the next clock, Q0 will always toggle. So this is changed from 1 to 0. 1 to 0 कौन से case में consider करते हैं? In the case of negative. Positive case में यहाँ पे you got 1 to 0. Will it activate this flip-flop? This won't be activated. ये कब activate होगा? When the value is changing from 0 to 1. But now the value is changing from 1 to 0. So this will not be activated. If not activated, then the output remains the same. Output remains the same. Now the value is changed from 1 to 1. So if it is changing from 1 to 1, this flip-flop will not be activated. If not activated, it will be returning the same output. So the output is 0, 1. It's the most significant bit. So it's 1, 1 and 0. Not in up or down छोड़ दो. Forget about this term. जो भी मैंने ब्रैकेट में लिखे है, this is up counter or down counter, just forget it. We are simply working on 3-bit triple counter. That's it. Up है या नहीं है, up है या down है, it depends on the sequence of the outputs that you are getting. Okay. Now when you will be applying the third clock, Q0 will toggle. Q0 will toggle. After this, when Q0 toggle, this is what? This is changing from 0 to 1. If it is changing from 0 to 1, it's changing from 0 to 1. This means that this will be activated. If it is activated, flip-flop 1 is activated, it will toggle its value. Now the change is 1 to 0. So this is considered in negative edge triggering, but we are working on positive. So the second flip-flop is not activated. So its output remains the same. Clear? बच्चे second activate कैसे होगा? Second flip-flop is not activated because Q1 की output क्या change हुई है? It is changed from 1 to 0. It is changing from 1 to 0. But ये activate कब होगा? When it will be changing from 0 to 1. Positive का मतलब क्या है? Changing from 0 to 1. I guess some confusion is there. Yes, second won't be activated. Right? So second is not activated, so the output remains the same. Apply the next clock. Q0 will toggle. This is toggling from 1 to 0. This means that flip-flop 1 will not be activated. Right? If flip-flop 1 is not activated, so the output remains the same. Output remains the same, 0 to 0. It's not 0 to 1. So flip-flop 2 will not be activated. Its output remains the same. So it is generating 1, 0, 0. Similarly, determine the output for 5, 6, 7, 8 and see कहाँ तक जाएगा ये. Yes. So 5 के case में this will toggle. Now this is changing from 0 to 1. This will activate the flip-flop 1. So this will be changing its value from 0 to 1. It's changing from 0 to 1. So this will toggle its value. So it comes out to be 0. Sixth clock, toggle. Changing from 1 to 0, flip-flop 1 will not be activated, output remains the same. 1 to 1, flip-flop 2 will not be activated, output remains the same. 7th, toggle. Value is changing from 0 to 1, so this flip-flop 1 will be activated, output will be 0. 1 to 0, flip-flop 2 will not be activated. Clock 8. This will toggle, changes 1 to 0, this won't be activated, 0 to 0, this won't be activated. वापस से आपके पास कौन सी स्टेट आ गई जो आपके पास 0th स्टेट अवेलेबल थी, दैट इज द इनिशियल स्टेट. तो टोटल कितनी स्टेट्स आई हैं आपके पास? डिफरेंट स्टेट्स आर 8 स्टेट्स, दैट इज नथिंग बट 2 raised to power 3. Why is this known as down counter? If you look at the values, this is the binary of 7, this is the binary of 6, this is the binary of 5, this is the binary of 4, this is the binary of 3, this is the binary of 2, binary of 1, binary of 0. So this is nothing but down counter. That's why this is known as down counter. Reverse order, yes. So now is this clear that when a counter is known as down counter and when a counter is known as up counter? Okay, so in this case we have positive clock and connected with the uncomplemented output, so it is behaving as the down counter. आपको try कौन से cases करने? Take the positive clock, instead of connecting it with the uncomplemented output, connect it with the complemented output and then see that what output you are getting. Okay, so basically you will be having 4 cases. If it's the case of negative edge triggering and the input is connected with the uncomplemented output, then it will be behaving as an up counter. And with negative, आपको बच्चे directly counter given होगा and they may ask that the given counter is the up counter or the down counter. आप sequence generate करके भी देख सकते हो और directly you can return that if the counter is the up counter or down counter. So for this one we have discussed the case. For this one also we have discussed the case. तो बाकी 2 cases आप try कर सकते हो. जो भी आपकी queries होंगी, when I'll be talking about the previous year questions, I'll be taking a session on the previous year questions. At that point of time, we'll discuss the doubts. All right? Any doubt till this point? So now we are left with just one concept, that is designing of asynchronous counter. We have talked about the designing of synchronous counter. Next we have designing of asynchronous counter. So in the asynchronous counter, first of all write the counting sequence. Whatever counting sequence you have to tabulate the values of reset signal. बच्चे आपके पास 2 signals आते हैं. One is the reset and other one is the preset. Reset and preset. What is the difference? Because if some sequence, obviously जो भी आपके पास asynchronous counters होंगे, these will be either the up counter or the down counter. For example, if I want to construct a counter for the implementation of BCD means 0 to 9 states I have to use. Ma'am, whenever we will be having a session on questions, then that would be on the basis of these topics or would include entire syllabus questions. First of all, I'll be taking the questions जो आपके पास first session होगा discussion का, that will be based on counters, registers and flip-flops. Or basically that will be, I'll be discussing the questions on the basis of sequential circuits. Not entire syllabus, just the sequential circuits which will include the flip-flops, registers and counters. So what is reset and preset? What is reset and preset? Reset का मतलब क्या? Okay, I was discussing about an example. So if you want to design a counter for BCD, asynchronous counter या तो आपके पास up counter होगा या फिर down counter होगा. If we want to construct a counter for BCD, तो यहाँ पे states क्या होती है आपके पास? 0 1. What is the sequence? It's 2 3 4 5 6 7 8 and up to 9 it goes, and again it will come back to 0. So basically total 10 states are used. To implement, to represent 10 states, we need to use 4 flip-flops. 4 flip-flops use करके आपके पास total combinations कितने आएंगे? 16 combinations. But among these 16 combinations, I have to use just the 10 combinations, that is 0 to 9. 9 के बाद वापस से इसको कहाँ पे आना है? It has to come to the 0. So this means that it will reset. It will reset to the initial state. Reset to the initial state. Preset का मतलब क्या है? It will preset it with some input, with some values. So that is the difference between preset and the reset. Or simply you can call this as clear. जो भी आपके पास outputs available है, just clear all those outputs and it will restart from the first input, from the first state. I'll be discussing that with the help of examples. Okay, so we have to construct, we have to tabulate the values of reset signals and R for various state of counter. And after that, we have to get the minimal expression for R and R complement using K map or using some method. And then accordingly, you can provide the feedback and you can construct the counter. So let's consider one example for asynchronous counter design. Write down the question. Question is, I want to design a counter in which there are 6 states. और अगर आपके पास modulo counter है, mod 6 का मतलब क्या है? If it's mod 6 counter, what do you mean by 6? This means that your counter is going to count 6 states. Okay, mod 6 means 6 states. Mod 6 will give you the कौन सी values आ सकते हैं? What is the sequence possible? The remainder can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5. After that, it will be going back. So 0 to 5. So this is the sequence. So in order to represent, in order to construct a mod 6 counter, how many states, how many flip-flops are required? I want to design and implement a mod 6 counter, mod 6 asynchronous counter using T flip-flop. This is the question. Now, first of all, we need to consider the clock pulses with 6 states. How many flip-flops will be used? Number of flip-flops will be 3. With 3 flip-flops, you can represent from 0 to 7. तो आपके पास total clock pulses कितनी apply होंगी? Total states कितनी आएंगी? 7. So let's consider this as 0, 1, 2, 3, 4, 5, 6 and 7. These are the possibilities with 3 flip-flops. Now the states we have to consider. States are, let's assume Q0, Q2, Q1 and Q0. And we have to determine what should be the value, कब जाके ये reset होगा, कब value reset होगी. If reset is equal to 0, this means that that won't be activated. If it is 1, that means that will be activated. Or simply you can consider this as clear or clear complement. So you can use any one. So accordingly you have to change the gates, right? Now here the output will be 0 0 0, it's 0 0 1, 0 1 0, 2, 3, 4, 5, 6 and 7. What will be R? 0 आउटपुट जनरेट करने के बाद क्लियर करनी है आउटपुट्स? नो, नॉट रिक्वायर्ड. कब जाके क्लियर होगी? 5 तक you have to return the output. You have to note down the output. जैसे ही आपके पास 6 आएगा, it needs to reset. Till this point, the value of R, that is reset, remains 0. Correct? First clock apply करके जो output आएगी, we have to note down that output. First clock के बाद we have to note down the output. Second के बाद we have to note down the output and so on. जैसे ही आपके पास 6 आएगा, after 6 it will be reset. And what about 7? Should I write here 1? No. जब 6 पे reset हो गया, 7 पे कभी control आएगा ही नहीं. So let's not consider the clock 7. Right? यहां तक क्लियर हुआ? Now, whatever we have in mod, we should take one less than that to use in reset. Basically, बच्चे इस तरीके से आप इसको क्रैम मत करो. Just you can consider this as कि आपके पास जब आप कोई भी mod n लेते हो, for example, if I am dividing some number, mod का मतलब क्या होता है? What will be the remainder after dividing that number, after dividing some number by a particular number? So if it is mod 6, किसी भी number को जब आप 6 से divide करोगे, तो possible remainders क्या आते हैं? That is 0, 1, 2, 3, 4, 5. Right? So this means that total 6 states are represented. तो 6 तक it won't reset. जैसे ही आपके पास next remainder आएगा 6, अगर आपके पास number 36 है और 6 divided by 6, it will go back to 0. So that's why here we are going to reset the value. Clear? Now, can you determine that in what case it is resetting the value? कब value clear करनी है? Now, let's before designing the circuit diagram, let's consider one more thing. If the input is Q complement, and you are using the clear complement, not, then in that case, it will be using what gate? It will be using OR gate. If it is Q complement and clear, then it will be using the NOR gate. If it is Q and it is clear complement, then it will be using NAND gate, and if it is Q and clear, then it will be using AND gate. You can use the bubbles or is what? That is bubbled NAND. NOR is nothing but that is bubbled AND. NAND is nothing but that is bubbled OR. And AND is nothing but this is bubbled NOR. वैल्यू कब रीसेट हो रही है? फर्स्ट ऑफ ऑल लेट्स सी कि जो आप एसिंक्रोनस काउंटर डिजाइन कर रहे हो, व्हाट आर द कनेक्शंस? यहां तक विजिबल है? क्लियर कॉम्प्लीमेंट इज इफ यू आर यूजिंग हियर नॉट, क्लियर को रिप्रेजेंट कर रहे हो विद द नॉट. फॉर एग्जाम्पल, if let me draw this T flip flop. This is something like T1, T2, T3. आप कुछ भी ले सकते हो, just the numbering. Q1 complement, Q2 complement, Q3 complement. यहाँ पे वैल्यू क्लियर कब करेगा? जब क्लियर की वैल्यू इज 1, then it will clear all the values. If you are taking clear complement, तो इसका मतलब क्या है? वैल्यू क्या होनी चाहिए आपके पास? It should be, your gate should be producing the output as 0, then only it will be clearing the value. It's just like Q and Q complement. Correct? ये activate कब होगा? When it will be clearing all the values, when the output is 0. यहाँ पे मैं clear complement वाला एग्जाम्पल लेती हूँ, don't worry. So if it is taking the bubble and it is connected with, it is working on negative edge triggering, some inputs are fixed, these are fixed to 1. Now how will you be getting the connections? We have to use the concept of clear complement, and let's assume that the output, this clock is connected with the uncomplemented form. So if it is connected with the uncomplemented form and it's using the clear complement, yes, better idea is just, if you can remember these rules, this will help you out. Although asynchronous counter design पे अब तक कोई question नहीं आया है. Okay, so in this case, if it is connected with Q and you are using clear complement, then in that case NAND gate will give you the output. So here we need to use one NAND gate which will be behaving as the clear. This will clear, outer clock is applied. It will clear or it will reset the outputs of the flip-flops. What should be the connections for this NAND? कहाँ पे जाके value reset हो रही है? Where the value got reset? Value got reset at this position. So this means that this will not be considered. Here we are getting 1. So that is nothing but Q2 and Q1. Okay, I have taken this as, let me write this as Q0, Q1 and Q2. So it is 1 for Q2 and Q1. So जैसे यहाँ पे आपके पास value आएगी for Q1 and Q2, it is connected with Q1 and Q2. Here we are getting the output, so this will be giving you the expression that it's Q2, Q1. What is the 6? Captain Rogers. Is this clear? So basically on the basis of this, I got an equation. बच्चे यहाँ से आपको मिनिमाइज्ड इक्वेशन मिल जाएगी. दिस इज इन द सीक्वेंस. सो दिस इज Q2 complement Q2, Q1 complement Q0, Q1 complement Q0, Q1 Q0. I have got the expression Q1 Q0 complement. We just got the expression, this is 1 and this is 0. So it's going to form a pair. And what is the equation for R? For R, ये कब reset करेगा? When it is Q2, it's connected with Q2 and Q1. So it's connected with Q2, one of the input is Q2 and other input is Q1. Right? So just you have to determine the value कि कहाँ पे जाके it has to reset the value, and on the basis of that get the minimized expression and implement this. Gate कौन सा use होगा? Inputs आपको मिल गई gate के लिए. Gate कौन सा use होगा? You can determine the gate on the basis of this table. This is how an asynchronous counter can be designed. Any doubt in the designing of asynchronous counter? सी डिजाइनिंग पे बच्चे क्वेश्चन नहीं आया है, बट आई हैव कवर्ड ऑल द कॉन्सेप्ट्स ऑफ काउंटर्स. तो इसके बेसिस पे क्वेश्चन ये आ सकता है कि कौन सा गेट यूज होगा एंड व्हाट विल बी द इनपुट्स फॉर दैट पर्टिकुलर गेट. They can ask a question on the basis of the inputs. They'll say that NAND gate is used क्योंकि आप NAND भी use कर सकते हो, आप bubble भी use कर सकते हो. For that gate, what will be the inputs? So here, what are the inputs? That is Q1 and Q2. So basically, they will be asking for the equation. और synchronous counters में भी यही है. अगर आपको equations find करनी आती है, then this means that the concept is clear. So this is all about counters. We have covered the different types of counters, synchronous counters and asynchronous counters. Special type of synchronous counters, ring counter and the Johnson ring counter, and we have also calculated the number of states, and also we had looked at the designing of synchronous and asynchronous counters. For equation, and ma'am, for equation need to solve everything. Everything is what? यहाँ पे everything तो कुछ है ही नहीं है बच्चे. What do you mean by everything? जो भी equation पूछिए just उसके लिए solve करो. Okay? Whatever is asked in the question, just solve for that equation. You need not to solve for everything, but definitely you need to get the output. क्योंकि जब आपके पास आउटपुट आएगी, ऑन द बेसिस ऑफ दैट यू हैव टू लाइक नीड टू ड्रॉ. नो, यू नीड नॉट टू ड्रॉ एनीथिंग. दैट इज द इम्प्लीमेंटेशन. ड्रॉ करने की जरूरत नहीं है. इक्वेशंस मिल जाएंगी, तो इक्वेशन के बेसिस पे यू कैन टेल दैट व्हाट शुड बी द इनपुट फॉर व्हाट गेट. ज्यादा से ज्यादा आपसे इनपुट और कौन सा गेट यूज हुए, और दे मे आस्क फॉर द इक्वेशन. दैट इज इट. This is not a subjective paper, right? Okay. Now let me discuss the schedule. After onwards, after this session, we won't be having any session in the morning at 11:30. So daily we will be having the sessions on YouTube and special classes daily, but I'll tell that what are the exceptions. We will be having the session at 7 p.m. to 8 p.m. मैम एक क्वेश्चन है फ्रस्ट्रेटेड इंसान को. बताओ फ्रस्ट्रेटेड इंसान क्या क्वेश्चन है आपका? 4:30 p.m. to 5:30 p.m. In this daily we are having two sessions. In this we are covering the concepts of computer organization and architecture, and under the YouTube we are covering the concepts of data structures and programming. Yesterday we had started with the concepts of trees. बच्चे थोड़ी सी theorems रह गई थी, but today next session is already planned, that is on BST. So I'll be covering the theorems. I'll let you know that when we will be covering the theorems. फ्रस्ट्रेटेड इंसान का जो क्वेश्चन है, आई डोंट थिंक दैट दिस इज द वैलिड क्वेश्चन, और आई एम सपोज टू आंसर दिस क्वेश्चन. If you have question related to some technical topic or related to digital or some other subject or related to gate preparation, then I can handle your query. Queries like आपके टूथपेस्ट में नमक है or something like that, this is not the right place to discuss these type of questions. Previous year on questions on algorithms, definitely I'll take that. So today we will be having a session at 7 p.m. in which we will be covering the concepts of BST. Tomorrow we will not be having YouTube session. Tomorrow we will be having today we will not be having any special class. Exception is except Saturday, and this is except Sunday. Sunday and Wednesday. This is except Saturday and Wednesday. Okay. Now tomorrow we won't be having, since tomorrow is Sunday, so tomorrow we won't be having no YouTube session. But tomorrow we will be having 2 special classes. वैसे special classes के मैं topic announce कर रही हूँ, very very important. एक topic के लिए आप काफी time से बोल रहे हो, that how to effectively utilize the last 60 days of the GATE preparation. Approximately 2 months to go for the GATE 2021. So this session will be very useful for the students, those are targeting on GATE 2021. So it will be at 8 p.m. 8 p.m. to 9 p.m. Effective preparation strategy. For last 60 days. And other session will be at the standard timing, that is 4:30 p.m. In this we will be covering the instruction set. Instruction set. So today our next session will be at 7 p.m. So I'll see you in that session, and if you want to follow the special classes, these special classes are free of cost. Anybody can access these classes, but before accessing the classes, you have to apply the referral code, and you can use the referral code, that is Shefali, to follow my sessions. Ma'am, Monday will you take special class? Definitely I'll take a special class on Monday. But Monday we won't be having a special class on previous year questions on counters. Previous year questions on counters पे जो special classes है on sequential circuits. This is a note on sequential circuits. I'll be taking these questions in the special classes starting from Tuesday. And after finishing these questions, we will be discussing the previous year questions on algorithms in the continuation. So I'll come up with a previous year question series. So this will be starting from Tuesday. Any other query? Clear to everyone, right? तो बच्चे अब आपके पास 2 दिन का टाइम है, संडे और मंडे. जितने भी आपके पास क्वेश्चंस है सीक्वेंशियल सर्किट्स पे, solve all those questions. Revise the concepts, whatever we have discussed in today's session, and on the basis of that, whatever queries you will be having, I'll be handling those queries on Tuesday. Okay? Great. So this is all about this session. Before ending the class, हमारा जो मूल मंत्र के success basically depends on your practice level. So success is directly dependent on the practice. So do practice, practice, practice. So we know that today it is the age of competition. Everywhere so much competition is there, and all the competitive exams are based on 3 factors. One is the speed, accuracy and logic, and it requires constant practice from the very beginning. So if you are in the second year, third year or first year of BTech, आप अभी से practice शुरू कर सकते हो, so that कि आप third year के end तक अच्छे से prepare कर लो. And if you are in the 4th year, तो बच्चे आपके पास beginning वाला time है. This is the high time to solve the questions, to participate in the live quizzes and to write the tests. Any doubt from your side? If no queries there, we'll end the session. And those who are watching this session for the first time, guys, you can join our Telegram group, that is Let's Crack GATE CSE. And the link of this group is given in the description box for your convenience. And definitely if you like this video, click on the like button, subscribe the channel, hit the bell icon for the notifications of new videos. In case you are having any doubt, you can write in the comment section. If you have any feedback or suggestion, feel free to fill out the feedback form. And to join the special classes, free classes, don't forget to apply the referral code. And if you want to join the crash course, you can go for the plus subscription or the iconic subscription. And in that case, to get 10% discount, apply the referral code. So this is all about this session. I'll see you at 7 p.m. in which we will be covering the concept of all the concepts of binary search tree. So this is all about this session. Thank you guys. God bless you.